Hello there, and welcome to the sleepy sky. Tonight, a small corner of the world grows softer around you, as if the air itself has decided to loosen its hold and rest. Whatever the day has asked of you, whatever thoughts still circle at the edges of your mind, they can set themselves down for a while. You have arrived in a quiet place, a gentle in-between, where questions do not demand answers, and the only task is to drift. Let your shoulders ease, let your jaw soften, and let the night unfold like a slow, calm tide. A slow, calm tide seems to move through the room now, almost invisible, yet easy to feel. You might notice the faint whisper of fabric against skin, the coolness of air at the tip of your nose, the steady rhythm of your own breathing as it flows in and out. These small sensations are markers of the present moment, tiny anchors that do not pull you down, but allow you to float in something steady and safe. Nothing is expected of you here. It is more than enough simply to listen, to lie still, to let the story move around you like a soft and endless current. Like a soft and endless current. This story is not here to challenge you or test you. It is here to carry you, slowly and steadily, through the edges of what we know and the wide spaces of what we do not. Even in a world overflowing with research and data, with instruments that can listen to the sky and peer into the smallest cells, there are questions that remain untouched. Like distant lights on a misty shoreline, scientists walk toward them, one careful step at a time, yet the lights keep moving, inviting, never quite within reach. In that shimmering distance, something deeply human relaxes. It is all right not to understand everything, and it is gentle to let unfinished thoughts rest. It is all right not to understand everything, because mystery is not a failure. Mystery is the soft fabric between the stars, the gentle pause between thoughts, the quiet interval in a heartbeat when the heart is neither contracting nor resting. Yet, in those pauses, in those in-between spaces, the mind can loosen its grip. You do not have to hold the universe together. You do not have to hold your day together. For this stretch of time, you can let every unsolved piece drift to the edges, like leaves falling onto still water. Every question can float there, unhurried. For now, your only work is to breathe as slowly as you wish, knowing this moment is kind to you, as slowly as you wish. Your attention can widen from this room to the sky beyond it, above the ceiling, above the rooftops and trees. There is the wide dark of space, wrapped around the planet like a silent ocean. We know that most of what exists out there is invisible to us. Astronomers tell us that the stars, the gas, the glowing dust we can see are only a fraction of the universe's true content. The rest is something we call dark matter and dark energy. Not because they are sinister, but because we cannot see them directly, cannot touch them, cannot yet explain them. They reveal themselves only through their gentle influence, the way they bend light, the way they guide galaxies as they slowly turn, as they slowly turn. Those galaxies are held together by something we can measure but cannot fully name. The visible stars would not be enough to keep them from drifting apart. There must be more, a hidden mass, a silent framework stitched through space. So the universe holds a secret weight, a quiet structure that cradles everything without revealing its own shape. This hiddenness can feel strangely comforting. Even on nights when you feel scattered or uncertain, you are still nested within a pattern far larger and more patient than any worry. You are resting inside a cosmos that does not rush to explain itself, and you are allowed to rest with it. A cosmos that does not rush to explain itself invites you to slow down too. You can allow your thoughts to move like distant satellites, orbiting more slowly, losing urgency with each quiet loop. Questions about tomorrow, about choices and tasks and unfinished plans can move outward gently to a calmer distance. They are still there, but they no longer press on your chest. You are allowed to be unfinished. You are allowed to be in between. Let every concern soften at the edges. Let every sharp thought blur like ink dissolving in water, until only gentle shades remain. And remind yourself that it is completely all right to release your grip until only gentle shades remain. Notice how your body responds. The muscles behind your eyes may loosen. The base of your skull may feel a little heavier against the pillow, supported and still. Your hands might rest more openly, fingers uncurling, palms settling into warmth. Even within your chest, there may be a subtle feeling of more room, as if the air has grown wider and kinder. In this space, you do not need to hold on to every idea that passes. They can drift through like quiet visitors, not staying long, not asking for attention. This moment belongs to your rest and to the quiet unfolding of wonder, and you are gently welcomed within it. The quiet unfolding of wonder begins with the simplest of truths. Despite centuries of study, we still do not know why there is something rather than nothing. We know that energy and particles, space and time, form the fabric of reality. We can describe their behavior with careful equations and thoughtful models. Yet, the question of why sits gently beyond our reach. Why does the universe exist at all? Why did it begin? These questions float at the edges of cosmology like soft lanterns in a dark lake. Scientists can map the shape of the cosmos, trace its expansion, measure the afterglow of its early moments, but the deepest reasons remain quiet. And in that quiet, the mind finds room to breathe. You do not need to wrestle with the origins of existence tonight. It is enough to know that you are part of something vast and continuous, something that has unfolded over billions of years, calmly and steadily. The atoms in your body were forged in stars that lived and faded long before you were born. The iron in your blood, the calcium in your bones, the carbon in your cells, all of them were shaped by cosmic furnaces, scattered through space and gently gathered into the form you carry now. You are, in a very literal way, a soft arrangement of starlight. And that starlight is allowed to rest, a soft arrangement of starlight, wrapped in skin and breath and quiet thoughts. When you rest, the universe is resting through you. When you exhale, the air moves through a pattern that was set in motion long ago, when the first stars kindled in the dark. Science can tell us how those stars form, how gravity draws gas together until nuclear fires ignite. It can describe the processes, the elements, the energies involved. Yet the feeling of lying here, aware of being made from that same material, is something beyond equations. It is a gentle, grounding awe. It is an invitation to feel small in a way that is safe and soft, and to know that smallness can be soothing, safe and soft. That is how this moment can be. You are not being examined. You are not being judged. You are simply existing, like a planet quietly orbiting its sun, steady and unhurried. Even thoughts that feel tangled can relax their grip when placed in this wider view. Compared to the long life of stars, to the slow turning of galaxies, every worry becomes a brief ripple. It does not mean your feelings are unimportant. It simply means they can be held in a larger, calmer frame. Let that frame support you tonight. Let it cradle your attention the way gravity cradles the moon. And allow yourself to lean into that quiet support the way gravity cradles the moon. Unseen forces cradle your own inner life. Science still cannot fully explain how consciousness arises from the physical structure of the brain. Billions of neurons exchanging tiny electrical signals somehow give rise to color, to sound, to memory, to the soft sense of you lying here now. This is one of the great open questions in neuroscience. We can observe brain activity, trace networks, and study patterns, yet the leap from matter to experience remains a mystery. Awareness is like a quiet light shining from within a complex forest, visible, but its source still hidden. Its source still hidden. Consciousness joins the long list of things science is still learning to understand. Instead of forcing this unknown into sharp focus, you can let it stay gentle. Your thoughts, your feelings, your drifting impressions are all part of this soft, luminous field. You do not need to define it or control it. You can imagine your awareness as a dim lantern placed on a calm shoreline, its glow touching only what is near, while the rest of the night stretches peacefully into the distance. The shore is enough. The nearby shapes are enough. The darkness beyond does not threaten. It simply continues, and you are allowed to rest where the light is mild. It simply continues, this long partnership between what we know and what we don't. Time itself flows in one direction, from past to future, and even that simple fact remains partly unexplained. Physics can describe the arrow of time, connecting it to increasing disorder, to entropy, to the spreading out of energy. Yet why we experience moments in a single order, why memories cling to the past and not the future, is still woven with unanswered threads. As you lie here, feeling the slow slide of seconds, you are sharing in a feature of reality that is both familiar and mysterious. And it is all right to let that mystery lull you, familiar and mysterious, like the feeling of drifting into sleep. You have done it thousands of times, closing your eyes, letting your thoughts blur, allowing awareness to thin and soften until dreams arrive. Yet, even now, the science of sleep is full of questions. We know some of what happens in the brain. We know that sleep helps restore, repair, and reorganize. But the deeper why of dreaming, the full purpose of each stage of sleep, remains gently unresolved. This means that tonight, as you approach rest, you are stepping into one of nature's oldest and most peaceful unknowns. Your own sleep is part of the unexplained beauty of life, and that beauty is quietly on your side. Part of the unexplained beauty of life is the simple truth that you do not have to earn your rest. Night comes, whether or not you solved every puzzle of the day. The body carries out its quiet processes, cells mending, hormones balancing, memories sorting themselves into calm patterns without needing your conscious help. There is an intelligence woven into your tissues, into your heartbeat, into the steady rise and fall of your chest. That intelligence does not rush. It is patient and kind. It keeps working even when your thoughts fall silent, and you can trust that silent work to continue, even when your thoughts fall silent. The world around you continues in its own gentle way. Somewhere, leaves are folding into darkness. Somewhere, water is moving slowly over stones, carrying tiny grains of sand. Somewhere, far beyond the thin shell of atmosphere, particles are streaming through space, guided by laws we only partly grasp. You are lying within this vast, quiet network of events, each one small and steady, each one part of a rhythm larger than any single life. You can let that rhythm soothe you, the way a slow and steady drum might calm a restless heart, and know that you belong in that rhythm. Calm a restless heart by reminding it that it is not alone. You are part of a universe that holds more questions than answers, and that is not a problem to be fixed. It is a landscape to rest within. All the gaps in our understanding, the nature of dark matter, the source of consciousness, the origin of time, the reasons for life itself, these gaps are not empty. They are filled with possibility, with patience, with the quiet promise that there will always be more to discover. And for tonight, more to discover simply means more room to relax into, more space in which your thoughts can grow quiet, more room to relax into as the edges of your awareness blur and soften. If any thought still clings a little too tightly, you can imagine placing it gently on a shelf at the side of the room, knowing it will be there if you need it later. For now, the shelf can hold it. The room can hold you. The night can hold the room. Layer upon layer, you are surrounded by calm. Everything that is unresolved can float above you like distant, soft lights, faint and unthreatening, slowly dimming as your breathing deepens and your body trusts the stillness as your breathing deepens. Feel how the story has already begun to move from the surface of your mind to a quieter place beneath it. We have touched the unknown weight of the universe, the hidden patterns of matter and thought, the soft questions of time and sleep. We have not needed to solve them. We have only needed to notice how gently they glow at the edges of what we know. Mystery has shifted from something sharp to something soothing. It has become a blanket rather than a wall, a gentle covering for the restless parts of you, a blanket rather than a wall. That is what the unknown can be for you now. It can cover you lightly, keeping you warm without pressing down. It can dim the brightness of the day, allowing your senses to rest. Every unanswered question can be a star, and every star can be a point of quiet, guiding you not to urgency, but to surrender. In this soft, widening darkness, curiosity is allowed to lie down beside calm. Awe is allowed to close its eyes, and thought is allowed to slow to a peaceful hum. And in this meeting of curiosity and calm, the night grows deeper around us, inviting us onward into the first of many gentle enigmas, where the questions do not disturb the silence, they deepen it, and we drift on within that deepening hush. Consciousness has always been a gentle question at the center of human thought, a quiet flame that glows without revealing its source. We wake into awareness each morning, we drift out of it each night. And yet science is still tracing the soft edges of what it truly is. There is nothing else in nature quite like the inner light that flickers behind the eyes, the way sensations gather into meaning, the way thought rises from silence and dissolves back into it. As the night deepens around us now, this chapter settles into that mystery with slow, steady breaths. letting its calm shape the rhythm of the story, letting its wonder unfold like a drifting river of light. A drifting river of light seems to move through the mind when we imagine what consciousness might be. Billions of neurons communicate through tiny electrical pulses, each connection small and fleeting, yet together they create the world as we know it. Science can map networks, track signals, model patterns, and still, the essence of awareness remains untouched. We can measure activity, we can name regions, but we cannot yet point to a single place in the brain and say, this is where the glow begins. Instead, the experience of being alive emerges everywhere at once, as if every cell contributes a whisper to the quiet song of self. The mind brings its memories, sensations, emotions, and imaginations. Some appear gently, like the brush of wind across a still lake. Others fall suddenly, like a warm rain on soft soil. Scientists call this integration, the mind blending inputs into a seamless story, yet the experience is far richer than the vocabulary that describes it. The feeling of warmth on skin, the scent of a familiar place, the sense of time moving in one direction. These experiences arise within consciousness with such ease that we rarely notice their complexity. They seem simple, natural, inevitable, but beneath them is an architecture more intricate than any machine, more intricate than any machine. This architecture moves with slow, steady intention. Each neuron fires or rests, sending signals through long, branching pathways. The brain consumes significant energy for its size, continuously active even in sleep, humming with patterns that shift and rearrange themselves with each passing moment. Yet no matter how much we understand about those patterns, we still do not know how they produce the inner experience, the sense of being someone, the subtle feeling of having an inner world. That world cannot be imaged, scanned, or measured. It exists only within, like a soft lantern glowing behind a curtain, seen through its light but never directly observed. Seen through its light, the mind becomes a place of drifting imagery. Thoughts move like clouds across an open sky, forming and dissolving without effort. The brain produces them from electrical activity, but that activity cannot explain the quiet warmth of memory, the echo of emotion, the gentle rise of curiosity. These qualities, the soft interior textures of human life, exist in a space science is still learning to describe. They remind us that not everything can be reduced to mechanism. Some aspects of reality, especially the ones closest to our hearts, retain a kind of sacred softness. They invite understanding, but they do not insist on it. They invite understanding the way a dim shoreline invites wandering, not with urgency, but with gentle suggestion. Consciousness is such a shoreline. We stand at its edge while thoughts lap softly around our feet. Sometimes the water is clear, and we understand our own feelings. Sometimes it is cloudy, and the meanings remain hidden. Either way, the waves continue, steady and calm. This reminder that it is natural not to understand everything within ourselves can be soothing. It allows the mind to loosen, to rest, to drift. You do not need to solve yourself tonight. Your inner world can remain wide and gentle, a place where thoughts arrive slowly and fade even more slowly. A place where thoughts arrive slowly encourages reflection rather than analysis. When neuroscientists study the brain, they find patterns that correlate with awareness. Yet they cannot say why those patterns produce the personal feeling of seeing or hearing or remembering. This is known as the hard problem of consciousness, the challenge of explaining subjective experience. How do electrical signals become color? How do chemical changes become emotion? How does the physical become the personal? These questions rest at the intersection of science and philosophy, where the known and the unknown blend into a calm horizon. Into a calm horizon, the mind moves when we imagine the brain at rest. Even in stillness, the brain hums with activity. There is a resting state network, a gentle loop of regions that light up when the mind wanders, drifting between memories, thoughts, and sensations. It is in these moments, when the brain is not focused on a specific task, that the softest parts of consciousness show themselves: daydreams, emotions that have no clear source, the gentle feeling of floating between thoughts. This network reveals that the brain does not need external input to create inner landscapes. It paints them on its own, like a quiet artist moving through a dimly lit studio. Like a quiet artist, the brain shapes dreams as well. Dreams are one of the most vivid expressions of consciousness, yet their purpose remains uncertain. We know that they weave memories together, rehearse emotions, and blend fragments of experience into surreal scenes. But why the mind chooses these particular forms, why some dreams feel warm and some uneasy, why they fade so quickly upon waking, all remain open questions. Dreaming is a nightly reminder that consciousness is not confined to wakefulness. It flows through sleep, rising and falling with each stage of the night, carrying the mind into uncharted waters. We go whenever we close our eyes and allow ourselves to drift. Consciousness softens, edges blur. The sense of I am awake begins to dissolve into something quieter. This threshold, the space between waking and sleeping, is one of the gentlest states the mind can enter. Scientists call it hypnagogia. Images flicker like fading lanterns. Sounds melt into memory. Time becomes loose. The mind may feel as though it is floating or turning or sinking gently into warmth. This is not dreaming and not yet sleep. It is a soft descent, a natural invitation to let go. A natural invitation to let go appears every few hundred words here, as a quiet reassurance to the listener. And so, let one come now. You can allow your thoughts to wander without pressure. There is no need to cling to anything. Let the night hold you gently. The reassurance is not a command, but a soft permission, the kind that relaxes the mind without effort. Consciousness responds kindly to softness. It quiets itself more easily when it feels supported, not instructed. You are allowed to drift. You are allowed to feel the weight of the day loosen its hold. We explore another layer of the mystery. Some scientists believe that consciousness arises from the brain's ability to integrate information into a unified whole. Others believe it emerges from particular patterns of complexity. Some think it may even be related to quantum processes, delicate events unfolding in the smallest spaces of the neurons. Yet none of these theories fully explain the warmth of emotion, the vividness of sensation, the delicate texture of a single quiet moment. Life is more than its components. Awareness is more than its mechanisms, and you are more than the sum of your thoughts. Consciousness is not just the flicker of electrical signals. It is the feeling of being alive, the sense of presence, the subtle awareness of lying in a quiet room while the world outside rests. It is the gentle ability to notice the sound of your own breath, the faint pulse in your fingers, the stillness settling into your chest. When you focus on these sensations, they grow softer and deeper, like ripples spreading slowly outward from a single drop of water. Ripples spreading slowly outward continue until they find the edge of the pond, then return as gentle echoes. In the mind, these echoes appear as recurring thoughts, memories, or feelings. Some echo in comforting ways. Some echo in ways that feel heavy. Yet all of them arise within the same quiet space, the same luminous field of awareness. A thought is simply a visitor. It stays briefly, then leaves. The mind does not need to chase it. This is part of the mystery, the way consciousness can hold so many impressions without being overwhelmed. The way it can return to stillness again and again. Return to stillness again and again, especially in quiet moments. There is a rhythm to it. Thought arises. Thought fades. Awareness remains. The observer within stays gentle and constant. Neuroscientists can describe the activity, but not the observer, the inner witness that watches sensations come and go. This witnessing presence does not have weight or form. It does not age in the way the body ages. It simply exists, a calm vantage point from which experience flows. This witness-like aspect of consciousness is universal, shared across cultures and eras, unmistakably human. Unmistakably human as well is the desire to understand ourselves. But even here, the mystery deepens. Why do we have an inner narrative at all? A voice that comments, reflects, imagines. Why do we dream forward into possibilities? Why do we look back into memory? Why do we wonder about the self? These are not purely biological questions. They are emotional, philosophical, existential. They shape the way we experience life, yet they remain softly unresolved. And that is not a problem. It is simply the way consciousness works, not fully measurable, not fully predictable, always shimmering at the edges, always shimmering at the edges, is the interplay between consciousness and the world. Every sensation begins outside the body, yet the experience of it takes shape within. A distant sound becomes a feeling. A faint scent becomes a memory. A gentle touch becomes warmth. The external becomes internal through processes we can describe but not fully understand. In this transformation, the world becomes personal. The cosmos becomes intimate. Each moment becomes a small universe of its own, held quietly in the mind's soft glow. Held quietly in the mind's soft glow are emotions too subtle to name. Calm contentment, gentle longing, quiet hope. A slow kind of joy that feels like sunlight diffused through fog. These emotions blend into the background of consciousness, shaping moods without demanding attention. They add color to experience, warmth to thought. Yet their origins remain elusive. Science knows that neurochemistry plays a role, but chemistry alone cannot describe the feeling of nostalgia, or the peace that arrives in silence, or the trust that builds in safe moments. Emotion is both biology and poetry, woven into the fabric of consciousness with delicate threads. woven into the fabric of consciousness with delicate threads, is also the sense of connection, the ability to feel linked to others, to imagine their thoughts, to understand their emotions. This empathy relies on brain networks, but it also reflects something deeper about being alive. We are social by nature. The mind lights up when it perceives others. Awareness expands when it feels seen or understood. These subtle connections remind us that consciousness is not isolated. It flows from person to person through language, through expression, through quiet presence. Even now, in this calm space, you may feel a gentle sense of being accompanied by the steady rhythm of the narration. Accompanied by the steady rhythm of the narration, the mind may begin to drift more easily. The words become softer. The thoughts become slower. Awareness becomes like a dim lantern on a quiet path, illuminating only what is necessary. This narrowing of focus is natural and soothing. It is part of the transition toward rest, part of the way consciousness prepares itself for sleep. And before we continue, here is another soft reassurance for you. You are drifting exactly as you need to. Nothing else is required. Let comfort move through you like a slow breeze. Let comfort move through you like a slow breeze, because consciousness responds to gentleness more than force. When we try to fall asleep, the mind often resists, tightening its grip on lingering thoughts. But when we allow rest to arrive naturally, without pressure, consciousness opens like a calm window, letting sleep slip quietly through. This is why stories like this one help, not through explanation, but through rhythm, imagery, and the slow softening of attention. The mystery of consciousness supports the journey. As awareness dims, the unexplored nature of the mind becomes a cradle rather than a question. A cradle rather than a question. That is the space we drift through now. Consciousness is often described as the brain's greatest achievement, yet it is also its greatest mystery. It is the lens through which every experience passes, and yet we cannot step outside it to see what it truly is. This paradox does not need solving tonight. It only needs to be appreciated gently, like a piece of music whose notes wash over you without demanding interpretation. The mind can rest within the night. It can lie softly in the space between understanding and silence. Lie softly in the space where attention feels weightless. Maybe you sense your thoughts thinning. Maybe your body feels a little heavier against the bed. Maybe time feels wide and slow. These are signs that consciousness is relaxing, allowing itself to loosen its boundaries. The edges between thought and sensation begin to blur. The mind becomes a gentle haze, warm and steady, ready to drift into deeper quiet. This is a natural part of the journey, a calm descent into a softer state of awareness. A calm descent into a softer state of awareness allows the last pieces of this mystery to settle. We may not know how consciousness arises. We may not know how thoughts form their meanings. We may not know why dreams shape themselves the way they do. But we can rest in the truth that the mind is capable of immense quiet, immense beauty, immense peace. And for tonight, that is more than enough. Let the river of awareness flow slowly. Let inner light dim without disappearing. Let yourself lean gently into the unknown, trusting that it will support you. And as this inner landscape fades to a gentle hum, the world outside the mind opens again, guiding us toward the quiet forces that move through the rest of the universe. Steady and soft, gravity moves through the universe like a slow, patient breath, shaping everything without ever revealing its full nature. It tugs galaxies into spirals, pulls oceans into tides, guides planets around their suns, and keeps life anchored to the surface of the Earth. Yet, even with centuries of study, even with equations that predict its behavior with astonishing precision, the essence of gravity remains partly hidden. It is a quiet force, steady and ancient, whispering through the dark in ways that ask to be felt rather than fully understood. Whispering through the dark, gravity is not loud or dramatic. It does not glow or flicker or burn. It simply holds things close, drawing them together with a softness that cannot be seen but can always be sensed. Every step taken presses slightly into the ground because of gravity. Every drop of water finds its way downward. Every stone rests where it falls. Yet, despite its familiarity, gravity is more mysterious than it appears. No one fully knows why it exists or how it connects matter across such unimaginable distances. What is known is this: space bends, curves, and stretches around mass, and gravity is the expression of that curvature. The curvature of space is one of the most quietly beautiful ideas in physics. Instead of imagining gravity as an invisible rope pulling objects, imagine space itself as a flexible surface. When something heavy rests on it, the surface dips slightly. When something lighter passes by, it rolls gently into that dip. No force is pulling it. The object is simply following the curved shape beneath it. This picture, discovered by Einstein and confirmed by decades of observation, is elegant. Yet even with this elegance, questions remain. Why is space flexible at all? What gives it the ability to warp around matter? Why does the curvature obey certain rules and not others? These questions linger like faint stars beyond the reach of telescopes. Beyond the reach of telescopes lie the vast spaces where galaxies drift. There gravity plays its slowest, grandest game. Galaxies rotate with such speed that, by normal physics, their stars should fly outward into the dark. Yet they do not. They remain bound in graceful spirals, held by something that cannot be seen. This invisible mass, called dark matter, makes up most of the matter in the universe. It does not shine, it does not reflect, it does not emit heat. It simply exerts gravity, quietly shaping the architecture of the cosmos. Quietly shaping the architecture of the cosmos. Dark matter forms vast halos around galaxies, creating scaffolds on which stars gather. Without it, the Milky Way would be a loose cloud instead of a luminous whirl. And yet, despite its profound influence, science still does not know what dark matter is made of. It might be particles unlike any known. It might be something more subtle, more abstract. The truth remains hidden, waiting in the deep silence between galaxies. Waiting in the deep silence between galaxies. Gravity continues its delicate work. It stretches light itself, bending beams around massive objects in a phenomenon known as gravitational lensing. Light, which travels in straight lines, curves when space curves. This bending reveals invisible structures. Through it, astronomers can map dark matter without ever seeing it directly. They trace the patterns of light from distant galaxies, watching how it distorts, how it warps, how it ripples like reflections in slow-moving water. These distortions whisper the presence of something unseen, something ancient, something that has been quietly shaping the universe since its earliest moments. Since its earliest moments, the universe has relied on gravity to gather matter into stars. A cloud of gas forms a slight clump. The clump grows heavier, and gravity deepens the curve of space around it. More gas drifts inward. More weight gathers. The center becomes dense and warm, and at last, a star ignites. This slow, steady collapse into light is one of gravity's gentlest miracles. With no sound, no urgency, no haste, gravity draws together the ingredients for starlight. Every star that has ever existed owes its birth to this quiet pull. Every star that has ever existed shines because gravity and pressure reach a delicate balance. Gravity presses inward. Heat pushes outward. The star rests in a state of equilibrium, glowing steadily for millions or billions of years. The light that reaches Earth, the faint glimmers seen through windows at night, the warm beams that fall on skin during the day emerged from this balance. It is a reminder that even the most intense energies can find stillness, and even the heaviest forces can create beauty. Even the heaviest forces can create beauty, and gravity is no exception. On Earth, gravity gives shape to mountains, rivers, valleys, and coastlines. Rain falls because of it. The ocean breathes in tides because the moon pulls on the water. The moon itself stays in orbit because Earth bends space around it. Everywhere gravity touches, patterns form. Leaves flutter downward in slow spirals. Water finds the lowest curve in the land. Snow settles in soft layers. These ordinary movements are echoes of a force that reaches from the smallest pebble to the largest galaxy. From the smallest pebble to the largest galaxy, gravity behaves in the same quiet way. It attracts, always attracts, never pushes away. It draws things closer with patience, with consistency, with gentle certainty. This simplicity is one of its puzzles. Every other fundamental force in nature has both push and pull. Gravity has only pull. Why this is so remains unknown. Its equation is simple enough to teach to children. Yet the reason behind the Poisson equation is still hidden in the universe's deeper structure. Hidden in the universe's deeper structure, physicists suspect might be particles called gravitons, tiny carriers of the gravitational force. But no one has ever detected such a particle. Gravity is incredibly weak compared to other forces, making its quantum nature hard to measure. Yet the weakness of gravity is essential. If gravity were much stronger, stars would burn too quickly. If it were much weaker, planets would never form. Life as we know it exists because gravity is precisely balanced. A delicate softness woven into the cosmos. A delicate softness woven into the cosmos also reveals itself in gravitational waves, ripples in the fabric of space-time. When massive objects like black holes or neutron stars collide, they send waves outward, like ripples spreading across a still pond. And just like ripples, they carry information about their source. These waves were predicted long before they were detected. When scientists finally captured them, the signals were astonishingly faint, softer than the movement of a single molecule. But they were real, proof that space itself flexes and trembles. Space itself flexes and trembles in ways too gentle to feel. Even now, as the world rests in night, tiny waves pass through the planet, stretching and compressing it in minuscule amounts. These motions echo events that happened millions or billions of years ago. Massive collisions, ancient spirals, cosmic dances that ended long before Earth existed. The universe is full of such memories. Gravity carries them silently across impossible distances, allowing us to glimpse the echoes of long-lost stars. Echoes of long-lost stars also rest in the dust beneath our feet. The iron in the core of the earth and in the blood of every being was shaped in supernova explosions driven by intense gravitational collapse. A star grows old, its fuel runs low, gravity overwhelms it, and it collapses inward before rebounding outward in a brilliant release of light and heat. This collapse and rebound scatter heavy elements across space. Over eons, these atoms drift, settle into clouds, gather into planets, and eventually become part of living bodies. Gravity draws them in. Life shapes them. In this way, every heartbeat carries a history older than the planet itself. Older than the planet itself is the gravitational story told by black holes. They are regions where gravity becomes so strong that nothing, not even light, can escape. Yet, contrary to popular imagination, black holes are not violent in the way storms are violent. They are quiet. They do not reach out. They simply wait, bending space so steeply that anything crossing a certain boundary cannot return. Black holes are perhaps the purest expression of gravity's nature, its ability to shape space, to influence time, to create edges where the laws of physics behave differently. Where the laws of physics behave differently, mysteries deepen. Gravity interacts with time in a way that still feels like poetry. The stronger the gravitational field, the slower time passes. This is not metaphor, it is measurable. Clocks placed high on a mountain tick slightly faster than clocks at sea level. Time moves differently for satellites in orbit than for people on the ground. Gravity shapes the flow of moments, stretching and smoothing them. Every second has its own landscape, sculpted by the mass around it, sculpted by the mass around it. Time becomes a kind of quiet terrain. It stretches near black holes. It smooths in empty intergalactic space. It shifts subtly here on Earth. Without gravity's gentle influence, time would not flow the way it does. The universal rhythm of past, present, and future would not feel the same. This interplay between gravity and time is one of the most elegant mysteries in physics, and one of the most calming to imagine. The universe is not chaotic. It is composed of gentle curves, soft stretches, quiet pulls. Quiet pulls also shape human experience at a smaller scale. Gravity affects the way the heart works, the way muscles develop, the way bones hold their strength. In space, without gravity's steady downward tug, astronauts lose bone density and muscle tone. Their hearts become more spherical. Their bodies adapt to a world without weight. Returning to Earth, they must readjust to gravity's embrace, regaining the sense of downward direction, the feeling of being held by the ground. The feeling of being held by the ground is one of gravity's most comforting gifts. It provides orientation, stability, a sense of place. Even in moments of emotional drift, gravity grounds the body in a simple, reliable way. And so here, as the chapter breathes slowly onward, a gentle reassurance rises for anyone listening. It is all right to settle into the support beneath you. The world holds you with quiet steadiness. Let your weight soften. Let calm find you easily. Let calm find you easily as the story moves deeper into the fabric of gravity's unknowns. Among the most puzzling questions is why gravity is so much weaker than other forces. A small magnet can lift a paperclip against the entire mass of the Earth, pulling downward. This imbalance is known as the hierarchy problem. Physics has theories, but no definitive answers. Some propose hidden dimensions. Others suggest new particles. Others hint at subtle symmetries in nature. Yet none fully solve the puzzle. Gravity keeps its secrets, offering glimpses but never revealing its core. Offering glimpses but never revealing its core, gravity teaches humility. It reminds the human mind that not every phenomenon can be captured by equations alone. Some aspects of reality are too vast, too subtle, too deep. The universe is layered with mysteries that do not threaten our understanding but enrich it. Gravity is one of those mysteries, familiar, essential, and still somehow beyond complete reach. Beyond complete reach, gravity shapes cosmic evolution. Galaxies are drawn together in clusters. Clusters form filaments. Filaments form a web-like structure spanning billions of light years. This cosmic web, the largest structure in the universe, exists because gravity pulled matter into long, delicate threads. Between these threads lie immense voids, regions nearly empty, where few galaxies dwell. The contrast is striking: dense filaments and quiet emptiness, woven into a pattern that resembles frost on a window or veins in a leaf. Veins in a leaf echo the natural geometry of the cosmos, showing how patterns repeat across scales. The branching of trees, the flow of rivers, the distribution of stars, all follow subtle mathematical harmonies. Gravity contributes to these patterns by guiding material into places where it can accumulate, settle, and grow. Even the formation of planets arises from tiny grains of dust drifting together under gravity's patient pull, sticking, merging, becoming larger, and eventually forming worlds. Forming worlds is another of gravity's gentle achievements. Dust and gas collapse into disks. Rings form. Over millions of years, small clumps collide, sticking through a combination of gravity and chemistry. Slowly, a planet takes shape. It cools or warms, depending on its distance from the star. Oceans may form. Atmospheres may rise. Life may emerge. All of this arises from the quiet persistence of gravity, guiding matter into forms that can sustain complexity. Sustain complexity is also what gravity does inside the Earth. The planet's molten core, driven by heat and pressure, generates the magnetic field that protects life from solar wind. Without gravity compressing the planet into its layered structure, the magnetic field might not exist. Without that field, Earth would be stripped of atmosphere and water. So gravity, in its silence, safeguards life in ways that cannot be felt but can always be appreciated. Safeguards life in ways that reach even into the smallest details. Gravity influences the flow of blood, the settling of cells, the orientation of plants as they grow. Roots sense gravity and move downward. Stems sense the same signal and move upward. Even microorganisms respond to gravitational cues, adjusting their movement to find nutrients or avoid harmful conditions. Life on Earth has been shaped by gravity so completely that imagining existence without it feels like imagining a world without air. Imagining a world without air brings to mind weightlessness, a state both peaceful and strange. Astronauts describe it as floating in gentle suspension, where every motion is soft and slow. Yet weightlessness reveals how deeply the body depends on gravity. Without the downward force, bones do not grow as strong. Muscles shrink. The sense of balance falters. These effects show how gravity is not just a cosmic force, but a physiological companion. It has guided the evolution of life from its earliest forms. Gravity also shapes the rhythm of sleep and wakefulness. Humans are used to lying down at night, letting gravity distribute blood evenly and ease pressure on the heart. This change in posture signals the body to shift into rest states. In space, without this natural cue, astronauts rely on other signals to manage sleep. This distinction illustrates just how intertwined gravity is with daily rhythms, even in ways rarely noticed. Rarely noticed is another aspect of gravity, its patience. Unlike storms or lightning or volcanic fire, gravity does not announce itself. It is a steady presence, always there, always working, always subtle. Its quietness is perhaps its most defining characteristic. It does not need to be loud to shape the universe. It only needs to be consistent. This consistency creates a foundation on which everything else rests. From the structure of atoms to the motion of galaxies, gravity spans a scale unmatched by any other force. Yet, despite its reach, it cannot explain itself. Physicists can describe how it works, but not why it works. This gap between description and understanding is where wonder grows, a space where scientific knowledge and imagination touch. And as gravity keeps its secrets, humans keep exploring, measuring, dreaming, searching for the missing pieces. Searching for the missing pieces becomes a quiet inspiration. The unknown does not have to be frightening. It can be restful. It can be a reminder that not everything must be solved for life to feel whole. The universe does not rush to explain itself. Its mysteries unfold over billions of years, in patterns so slow and steady they seem almost like breathing. This slowness is a comfort. It tells us that questions can remain open without losing their meaning. Questions can remain open without losing their meaning, especially when approached in stillness. And so, a gentle reassurance arrives again in the flow of the story. You may let every unanswered thing loosen inside your mind. There is space for the unknown. There is ease in its presence. Because gravity teaches that the unseen can be trusted. Even without understanding it completely, every being relies on gravity every moment of every day. It holds oceans in their basins. It shapes the orbits of moons. It steadies the feet of every living creature. It is the force that asks for nothing and gives everything. The force that asks for nothing and gives everything prepares the mind for a softer descent now. The universe bends, curves, and stretches in silence, shaping light, matter, and time. And from this gentle pull, from this soft and ancient thread woven through all existence, the story rises again, slowly, quietly, toward the hidden rhythms of something even more elusive, something that glows and vanishes in the same breath. And from this gentle pull, the mystery of light begins to shimmer. Light has always been the universe's quiet messenger, carrying stories across impossible distances, whispering through the dark with a grace that defies simple explanation. It moves with certainty, yet refuses to be defined by a single identity. Sometimes it behaves like a wave, spreading in soft, rhythmic ripples. Sometimes it behaves like a particle, a tiny point of energy traveling through space. This shifting nature is one of physics' oldest riddles, a paradox wrapped in radiance, glowing gently at the edges of understanding. Glowing gently at the edges of understanding. Light reveals a world of subtleties. It touches surfaces with soft color, bends around corners, scatters through mist, and floats across rooms in the early morning. Every beam that falls upon the earth has traveled through the vast darkness with astonishing speed, yet carries no rest mass. It does not weigh anything in the way matter does, yet it possesses momentum, the ability to push, nudge, and influence. This contradiction hints at deeper truths beneath the surface of reality, truths that science can describe with equations, but not fully explain in feeling. Not fully explain in feeling. Because light's presence is more than a physical phenomenon. It carries warmth, clarity, and a subtle emotional resonance. A single glimmer on water can evoke calm. A faint glow at dusk can soften the edges of the world. Even starlight, ancient, scattered, fragile, can evoke a sense of connection to something beyond the immediate moment. Light is both scientific and poetic. It reveals landscapes, yet also creates moods. It illuminates forms, yet also shapes emotions. Shapes emotions, too. In the way daylight stabilizes the internal rhythms of living beings, plants open to it. Human bodies regulate hormones in response to it. The cycles of sleep and wakefulness align with its presence and absence. Even the mind feels different under soft illumination, as if the brain responds not only to photons entering the eye, but to the gentle symbolism light has carried for countless generations. Yet the most extraordinary aspect of light is its dual nature, wave and particle, a mystery that remains unsolved despite more than a century of study. Despite more than a century of study, scientists still cannot fully explain how something can be both spread out and pinpointed, both continuous and discrete. When light passes through two small slits, it creates a pattern of interference, like a wave. When measured individually, the same light arrives as tiny packets of energy called photons. This is not a trick or illusion. It is the natural behavior of the universe. Light is not choosing between forms. It is simply being what it is, something richer and stranger than everyday intuition can hold. Something richer and stranger than everyday intuition. This duality inspires wonder. It invites deeper thought without demanding resolution. It asks the mind to accept that nature can be soft and shifting, that not everything must fit into a single description. In this way, light teaches patience. It shows that knowledge unfolds gradually, like dawn spreading through a quiet valley. Understanding takes time, and the unknown can coexist with certainty. settling comfortably beside it, settling comfortably beside it. Another aspect of light emerges, its speed. Nothing moves faster in the known universe. This limit, the speed of light, is a fundamental boundary woven into spacetime. It shapes causality, determines how information travels, and sets the rhythm of cosmic events. And yet, even with this constancy, scientists still wonder why light moves. Speed it does, not faster or slower. The reason remains hidden, tucked within the deeper structure of reality. Tucked within the deeper structure of reality is a connection between light and time. As an object moves faster, time slows for it. At the speed of light itself, time becomes undefined. Photons do not experience time in the way matter does. From their perspective, a journey across a galaxy may be instantaneous. This concept stretches human imagination, inviting thoughts to drift into wide open spaces. It suggests that reality operates on levels far beyond human experience. Levels where time and space lose their familiar meanings. Time and space lose their familiar meanings in another fascinating phenomenon, gravitational lensing. When light passes near massive objects, the curvature of space bends its path. Stars behind galaxies appear distorted or multiplied. Distant quasars form rings of brightness. Light travels the straightest possible route, but the routes themselves have been shaped by gravity. These distortions offer a way to see the invisible, revealing the presence of dark matter. The universe uses light as a brushstroke to paint its hidden structures. A brushstroke to paint hidden structures. That is how astronomers use light. They study how it stretches as the universe expands. They examine how it shifts toward red or blue. They measure its faint ripples, its subtle echoes, its delicate fingerprints. Every star, every nebula, every distant galaxy sends its story through light. The cosmos communicates not with words or sound, but with brightness and shadow, with color and absence. Color and absence shape the emotional texture of light as well. The warmth of golden hour, the silver blue of moonlit water, the dim glow just before sunrise. These hues feel calm, steady, and timeless. They create landscapes within the mind, soft and dreamlike. Even the darkness between sources of light has its own quiet presence, a velvety stillness that allows the smallest flicker to shine. Without darkness, light would lose its meaning. Without shadow, illumination would have no contrast. Their partnership creates a kind of cosmic balance. A kind of cosmic balance can be found in the way light interacts with matter. Photons can scatter, bounce, or be absorbed. They can excite electrons, creating chemical changes. They can heat surfaces, power photosynthesis, or trigger signals in the human eye. Yet despite these interactions, light never slows to rest. It is always in motion, always traveling, always carrying its energy forward. If captured by an atom, it becomes part of a different process. If reflected, it shifts direction, but it never settles. It has no mass to anchor it, and yet its influence shapes life in profound ways. Plants convert sunlight into energy, forming the foundation of nearly every food chain on Earth. Animals rely on light for navigation, timing, and perception. Human emotions respond to its rhythms. Even the seasons themselves are determined by the angle and duration of sunlight. Light is not merely a physical entity, it is a quiet architect of biological rhythms. A quiet architect of biological rhythms. Light has been guiding life since the earliest days of Earth, before eyes evolved. Simple organisms sensed brightness through proteins that reacted to photons. Before pigments formed, sunlight shaped chemical pathways in ancient oceans. Life adapted not only to heat and water, but to illumination. Entire ecosystems respond to the rising and setting of the sun, flowers opening and closing, nocturnal animals emerging from shade, tides shifting under the combined influence of moonlight and gravity. Moonlight and gravity share a subtle dance. Yet moonlight is only reflected sunlight, softened as it travels through darkness. It carries the same paradoxical nature, wave and particle, but in a gentler hue. The cool glow of the moon calms landscapes, smoothing edges and softening shadows. At night, when sunlight rests beyond the horizon, moonlight remains as a reminder of that distant, unreachable star whose energy feeds every living being on Earth. Every living being on Earth experiences light differently. To some, it is nourishment. To others, it is signal. To many, it is warmth. But beneath every interpretation lies the same enduring mystery. Light behaves differently depending on how it is observed. If measured as a wave, it spreads. If measured as a particle, it strikes in discrete points. This observer-dependent nature suggests that reality may not be fixed. It may shift softly depending on perspective. Shift softly depending on perspective. The universe reveals that the act of observation plays a role in the form light takes. This does not imply that consciousness shapes physics, but rather that measurement itself alters the behavior of quantum systems. The double-slit experiment is a perfect example. When photons pass through without observation, their behavior is wave-like. When detectors watch them, they behave as individual particles. This quiet paradox lies at the heart of quantum mechanics, a whispering reminder that nature may not conform to human expectations. Whispering reminder that nature may not conform to human expectations appears again in the phenomenon of quantum entanglement, which two particles become linked, their properties reflecting each other instantaneously across distance. Though not a direct property of light itself, photons are often used to study entanglement. They carry information between points without delay, suggesting that the underlying structure of reality connects places in ways still unknown. These subtle interactions feel like invisible threads woven through the fabric of space. Invisible threads woven through the fabric of space resemble the role light plays in revealing cosmic expansion. As the universe stretches, wavelengths of light stretch too, becoming longer and redder. This redshift allows astronomers to measure distance, motion, and age. The farther away a galaxy lies, the more its light. Some galaxies emit light that has traveled for billions of years, a quiet journey through empty darkness, arriving now as faint glimmers carrying ancient stories. Ancient stories linger in the cosmic microwave background, the afterglow of the universe's earliest moments. This faint radiation, once brilliant, now cool and soft, fills all of space. It is the oldest light in existence, a memory of a time before stars formed, before galaxies cooled, before the universe fully settled into its shape. This ancient light carries tiny variations, subtle differences in temperature that seeded the formation of galaxies. It is a quiet map of beginnings, spread across the sky. A quiet map of beginnings also appears in the behavior of photons within atoms. Electrons occupy specific energy levels. When they drop to a lower level, they release a photon. When they rise to a higher level, they absorb one. This dance forms the foundation of spectroscopy, the study of light and its interactions with matter. Every element has a unique spectral fingerprint, like a pattern of faint musical notes. By analyzing light from distant stars, scientists can determine their composition, temperature, and motion. This knowledge, carried by photons, helps map the cosmos without ever leaving Earth. Map the cosmos without ever leaving Earth. That is the gift of light. It is the messenger of galaxies, the storyteller of stars, the quiet keeper of cosmic history. Yet, despite all it reveals, light remains elusive. It chooses no single form. It follows no single rule. It behaves as both wave and particle, as both presence and motion, as both illumination and mystery. Science describes it with precision, yet its essence slips through the fingers like sand, slips through the fingers like sand. This mystery invites the mind to rest rather than grasp. Light's paradox is not meant to frustrate understanding. It is meant to soften it. The universe is not obligated to be simple or intuitive. It is free to be complex, gentle, subtle, and strange. And that strangeness can feel calming. It creates room for imagination. It opens space for reflection. It allows uncertainty to sit quietly, without pressure, without expectation, without pressure, without expectation. A gentle reassurance drifts in again. It is all right for the mind to wander. Nothing must be solved here. Let the mystery feel soft. Let the quiet be enough. Let the quiet be enough as the story turns to the nature of shadows. Shadows are not the absence of light, but the shape made when light is interrupted. They reveal the contours of objects, the softness of edges, the presence of surfaces. Shadows stretch longer in evening, shorter at midday, and change color in the hues of sunrise and dusk. In this interplay, light and darkness shape the world together, each giving meaning to the other, each giving meaning to the other. Luminescence and opacity form a delicate partnership. Some creatures produce their own light, bioluminescent organisms glowing in ocean depths, fireflies flickering in warm forests, fungi shining faintly beneath fallen leaves. These lights are chemical, not cosmic, but they carry the same gentle resonance, the same quiet beauty. Their glow is often blue or green, colors that move softly in the dark. These biological lights remind us that illumination is woven into life at every scale. From stars to cells. From stars to cells, light plays another essential role: energy transfer. When sunlight strikes a leaf, photosynthetic pigments absorb photons, triggering chemical reactions that build sugars. This process forms the base of nearly every food chain. Without light, ecosystems would collapse. Even in deep oceans where sunlight cannot reach, organisms rely indirectly on energy created by photosynthetic life at the surface. Light sustains the intricate web of life. Light sustains the intricate web of life. Yet it also carries the power to sculpt landscapes. Sunlight warms the planet unevenly, creating wind, weather, and climate. It melts ice, evaporates water, and drives the cycles that define the natural world. Without light, Earth would be cold, static, and lifeless. With it, the planet becomes dynamic, changing, awake. The contrast between day and night, warmth and coolness, brightness and shadow, creates the rhythm that life inhabits. The rhythm that life inhabits appears in subtle patterns of color perception. Human eyes contain cells that detect red, green, and blue light. These signals blend into the full spectrum, but other species see differently. Some birds perceive ultraviolet. Some insects see polarized light. Some deep-sea creatures see almost nothing at all. Light shapes the sensory world of every species, defining what can be known, recognized, and understood. Recognized and understood through light, the world takes form. Mountains, oceans, forests, and faces all derive their visible shape from the way they reflect or absorb photons. Without light, objects would still exist, but their appearance would be hidden. Light is the mediator between existence and perception. It reveals the contours of reality. Yet light also hides certain truths. Its speed limits what can be observed. Distant galaxies appear as they were billions of years ago, not as they are now. The farther one looks, the further back in time light reveals. This effect creates a quiet poignancy in astronomy. Looking outward is also looking backward. The night sky is a time machine made of photons. A time machine made of photons carries the past into the present. The color of a star reveals its temperature. The width of spectral lines reveals its rotation. The faint shimmer of distant clusters reveals the curvature of space. All of this knowledge travels as light. It arrives gently, without urgency, without force, without urgency, without force. The story can continue drifting deeper into calm. Light, with all its paradoxes, holds a softness that invites rest. Its mysteries are vast, but its presence is simple, a glow, a shimmer, a quiet radiance. Learning about its complexities does not disturb the mind. Instead, it offers a soothing sense of perspective. If even light, the most familiar of phenomena, contains such depth, then the unknown parts of life may be easier to accept. The unknown parts of life may be easier to accept when viewed through this lens. Light does not demand comprehension. It simply shines. It fills rooms, reflects off surfaces, and fades each evening into gentle dusk. It behaves according to laws humans have only partially uncovered, and it reveals only what it chooses. In this way, it mirrors the broader universe, generous with glimpses, sparing with explanations. Generous with glimpses, sparing with explanations. The paradox of light continues to inspire curiosity. Scientists may one day uncover the deeper reasons behind its dual nature. They may unravel the quantum mechanisms at its heart. But even if they do, the beauty of light will remain. Understanding does not diminish wonder. If anything, it deepens it, the way twilight deepens colors as the sun sinks low. Shadows lengthen, air cools, the last rays of daylight stretch across the horizon. In these moments, light becomes softer, more diffuse, more contemplative. This gentle transformation marks the boundary between waking activity and the quiet of evening. a daily reminder that the world shifts in cycles, each phase leading naturally into the next. Each phase leading naturally into the next. The story begins to follow light to its fading edge. As illumination gentles into darkness, another mystery rises from the deep past, a mystery not of photons, but of origins. Before stars shone, before planets cooled, before oceans formed, something stirred in warm mineral fields and ancient seas. And as light fades, another mystery stirs beneath the Earth's surface. Patient and ancient. Life began long before anyone could watch it unfold. Long before the first eyes opened or the first minds wondered. Its origins lie in a time when the Earth was young, wrapped in warm oceans and drifting mists, where minerals shimmered beneath ancient tides and the air carried a scent of change. This world was neither silent nor chaotic. It was a place of slow chemistry, gentle warmth, and quiet transformation. And even now, with all the scientific tools available, the very moment life sparked remains an unanswered question, a soft mystery resting at the edge of understanding. Resting at the edge of understanding. The early Earth was both familiar and foreign. Volcanoes breathed heat into the sky. Lightning flickered across wide oceans. Rivers carried minerals from young mountains into shallow coastal pools. Warmth rose from vents on the ocean floor, rich with chemical ingredients. In this world, molecules drifted, collided, and parted. Some lingered long enough to form chains. Some folded into shapes that could influence other molecules. Yet none of this directly explains how the shift from chemistry to life began. The line between non-living and living remains thin, subtle, and unresolved. Thin, subtle, and unresolved. The boundary invites imagination. One idea suggests that life may have emerged in deep-sea hydrothermal vents, where mineral surfaces created natural compartments for chemical reactions. These vents release warm water rich in hydrogen, sulfur, and metals, a perfect environment for early reactions. Minerals form small chambers, like honeycombs, where molecules can gather. Within these chambers, reactions unfold in cycles, supported by the gentle flow of heat and water. Energy moves through these spaces in quiet pulses, linking compounds together in ways that might, over time, create order. Order forming slowly over time echoes another hypothesis that life began in warm, shallow pools on the planet's surface. Sunlight, evaporation, and rain could concentrate ingredients over and over again, creating cycles of dryness and wetness. During the dry phases, molecules might have bonded into longer chains. During the wet phases, those chains could fold, interact, and grow more complex. This cycle mirrors a rhythm found throughout nature: expansion and contraction, dryness and water, heat and coolness, a slow beat that encourages complexity. A slow beat that encourages complexity also appears in another idea. Life may have begun on mineral surfaces, such as clay. Clay particles have unique structures, layered like pages in a book. Their surfaces can hold molecules in place, aligning them in patterns that make bonding easier. Experiments have shown that certain clays can help form long chains of RNA-like molecules, suggesting that minerals may have been the first scaffolds for early chemistry. These natural patterns, simple and quiet, may have guided the earliest steps toward life. Guided the earliest steps toward life. These environments share something important. They provide energy gradients. Life requires energy to organize itself. Whether the source was sunlight breaking through clouds, chemical reactions near vents, or electrical sparks from storms, energy flowed into the young earth in abundant forms. With each pulse, new combinations appeared. Some dissolved. Some endured. Some gained the ability to influence their surroundings. But the moment when influence turned into survival, when survival turned into replication, remains unknown. Remains unknown, too, is which molecule came first. Some theories point to RNA, a molecule capable of holding information and catalyzing reactions. RNA can copy parts of itself. It can fold into shapes that influence chemistry. It can form spontaneously in certain environments. This has led many scientists to propose an RNA world, a time when life was built around these versatile molecules. But RNA is fragile, prone to breaking. It requires specific conditions to form and function. Whether it truly preceded proteins, lipids, or other molecules is still debated. Still debated is the possibility that life began instead with simple metabolic cycles, reactions that allow energy to move in loops. These cycles could have existed before any molecules stored information. In this view, life started as chemical rhythms. Only later did molecules like RNA join these cycles, adding structure and stability. This idea paints the origin of life as a flow rather than a spark, a gradual increase in complexity rather than a sudden event. A gradual increase in complexity mirrors many processes in nature. Snowflakes form slowly from cold vapor. Rivers carve valleys grain by grain. Mountains rise through slow collisions. Even stars grow from drifting clouds. Nature seems to favor patience, letting things develop through repeated cycles. The origin of life may have followed this same pattern, slow, steady, unhurried, shaped by the quiet rhythms of the earth. Shaped by the quiet rhythms of the earth. Early life likely began as something simple, a small collection of molecules enclosed in a primitive membrane. These membranes may have formed spontaneously when lipids gathered in water, arranging themselves into spheres. Inside these spheres, chemical reactions could unfold in protected spaces. Molecules could interact more efficiently. Structures could form and dissolve. Over time, these tiny compartments may have gained the ability to take in nutrients, release byproducts, and maintain a delicate internal balance. Maintain a delicate internal balance is one of life's defining features. Cells regulate their internal chemistry with remarkable precision, keeping conditions stable even when the environment shifts. Yet the path from simple chemical cycles to this sophisticated stability remains a mystery. Perhaps early life did not control its conditions as precisely. Instead, it may have drifted between states, surviving when conditions were favorable and fading when they were not. This fragile existence might have persisted for millions of years, slowly improving its chances through random variation. Random variation continues to shape life today, but in the early world, it may have been the only source of innovation. Molecules that folded in more stable ways survived longer. Reactions that used available energy moved forward. structures that protected themselves endured. These small advantages accumulated. Eventually, the system may have crossed a threshold, moving from a cluster of reactions to a living organism. A living organism in those early days would not resemble anything modern. It would have lacked eyes, limbs, or sensory structures. It would not think or feel. It would simply exist, reacting to its environment in slow rhythms. But even this simple existence marked a profound transition. Chemistry had become biology. The earth had taken its first breath. The earth had taken its first breath, though no one was there to witness it. Life remained microscopic for billions of years. Simple cells drifted in oceans, multiplying slowly. They formed films on rocks, colonies near vents, and layers on the seafloor. Through photosynthesis, some released oxygen into the atmosphere, altering the planet forever. The breathable air of today is the result of ancient microorganisms working patiently across millennia. These early forms of life shaped the entire planet. They altered the chemistry of oceans. They changed the temperature of the atmosphere. They paved the way for more complex organisms. Yet the point at which complexity first emerged, when cells learned to work together, when organelles formed, when DNA became the main carrier of information, remains uncertain. Fossils from this time are scarce, and the chemical traces are subtle. Subtle clues appear in ancient rocks. Patterns of carbon isotopes suggest biological activity. Microfossils show tiny tubular structures that resemble early cells. Stromatolites, layered formations built by microbes, stand as fossils of ancient colonies. These records hint at life's slow progression, but they cannot reveal the exact moment when chemistry shifted into biology. That moment remains hidden in the quiet past. Lost but not forgotten, the origin of life continues to inspire gentle wonder. Even the simplest cell today contains thousands of interacting molecules. Proteins fold into precise shapes. Enzymes catalyze reactions. DNA stores information. Membranes regulate flow. Communication occurs within and between cells. This complexity suggests that life is not merely a result of random events. It is shaped by rules, patterns, and constraints that encourage organization. Organization is what nature often does. Crystals form orderly structures. Snowflakes build symmetrical patterns. Chemical reactions settle into steady cycles. Life may be an extension of this organizing tendency, guided by the physics and chemistry of the universe. Yet something sets life apart: its ability to change, adapt, and evolve. These qualities distinguish biology from mere chemistry. They hint at a deeper process that began long ago. Some scientists believe that life's origin required a specific set of conditions. Others think it may be inevitable wherever the right ingredients exist. Planets beyond Earth may harbor similar processes. Warm oceans, volcanic activity, and sunlight exist elsewhere in the universe. Perhaps life is not unique. Perhaps it arises whenever matter finds a way to organize into self-sustaining systems. Self-sustaining systems follow rules of balance. They must harness energy without destroying themselves. They must repair damage. They must maintain boundaries. These requirements suggest that life is not simply spontaneous. It is shaped by constraints that guide its form and evolution. Yet these constraints do not reveal how the first system emerged. That leap from inert to animate remains one of science's most enduring mysteries. One of science's most enduring mysteries is also one of its most peaceful. The origin of life does not need to be narrowed to a single moment. It may have unfolded across many steps, scattered across time and space. It may have begun in multiple locations, merging later. It may have started with simple cycles that only gradually became self-sustaining. This layered, patient pathway aligns with the calm progression observed throughout nature. A calm progression observed throughout nature also appears in stromatolites, ancient structures built layer by microbial communities. These formations rise slowly over centuries, capturing minerals from water. They show how small actions, repeated over long periods, can create enduring patterns. Life's origin may have followed a similar slow accumulation. Each layer building upon the last building upon the last. The early Earth nurtured diversity. Chemical environments varied widely, some hot, some cool, some acidic, some alkaline. Life may have experimented across these environments, trying different strategies for survival. Some attempts failed, others persisted. Over millions of years, the most stable systems outlasted the rest, eventually gave rise to cells capable of storing information in complex ways. DNA became the blueprint for life. Proteins became the workers. Lipids became the barriers. This division of roles increased complexity. It allowed life to diversify. It supported growth, specialization, and adaptation. Growth, specialization, and adaptation eventually led to multicellular organisms. But billions of years passed before this happened. For most of Earth's history, life remained simple. The complexity seen today, forests, oceans, animals, and human beings, rests on ancient foundations built in quiet, incremental steps. Those foundations were shaped not by sudden breakthroughs, but by steady, almost meditative processes guided by the gentle laws of chemistry and physics. Guided by the gentle laws of chemistry and physics, the origin of life stands as a reminder that profound change can begin in silence. It can begin in warm pools, in mineral crevices, in quiet ocean vents. It can begin in the smallest spaces, with the faintest movements. Complexity grows from simplicity. Warmth grows from reaction. Life grows from possibility. Life grows from possibility. And possibility itself is abundant in the universe. On icy moons like Europa and Enceladus, oceans exist beneath thick shells of ice. On Mars, past rivers carved valleys still visible today. On distant exoplanets, temperatures and chemistry may mimic early Earth across the cosmos. Life may have taken its first breath countless times, in countless forms, following quiet rhythms similar to those that shaped life here. Quiet rhythms shaped life here, as they shape many processes even now. Photosynthesis cycles with the rise and fall of the sun. Tides respond to the moon's pull. Seasons turn with the tilt of the planet. Every living being, from the smallest microbe to the tallest tree, moves with these rhythms. They echo the ancient beats that once gathered molecules into the first living systems, gathered molecules into the first living systems. These rhythms invite reflection. Life is not simply a collection of parts. It is a continuous process, flowing, renewing, evolving. Even now, every cell in every organism operates through chemical reactions that resemble those ancient beginnings. Energy flows, molecules bind, cycles repeat. The same principles that shaped the first sparks of life continue to shape life today. These principles offer comfort. Life has always adapted. It has always found ways to grow. It has always persisted through change, uncertainty, and difficulty. This resilience is built into the fabric of biology. It began in the earliest days of the planet and continues in every organism, and now a quiet reassurance drifts through the story, settling gently into the long arc of reflection. It is all right to let uncertainty be soft. The beginnings of life were gentle too, shaped by patience rather than clarity. Let calm reach the thoughts that stir. Let ease settle into them. Because the origin of life, for all its mystery, is a story of gradual emergence. It does not need to be solved in full to inspire awe. Its unknowns do not diminish its beauty. Instead, they amplify it, expanding the imagination, softening the heart, guiding thought toward wonder rather than conclusion. Life's first breath remains a quiet puzzle, one intertwined with the history of oceans, the warmth of early Earth, the chemistry of minerals, and the rhythms of cycles repeated millions of times. This puzzle is soothing, not because it is unsolved, but because it shows that existence does not require immediate clarity. Life began without knowing it was beginning. It unfolded quietly, steadily, patiently, guided by forces that continue to shape the world. And as life begins in quiet warmth, the story moves gently onward, drifting toward the mysteries life carries within, mysteries tucked not in oceans or minerals, but in the smallest spaces of matter itself, where particles drift like soft fireflies. Atoms appear solid in the imagination, small spheres packed together like grains of sand. Yet, in reality, they are mostly empty space, a quiet architecture of vast distances, delicate forces, and drifting particles. Inside each atom, electrons swirl through regions described not by paths but by probabilities. The nucleus sits at the center, dense and tiny, while the electron cloud spreads around it like faint mist. This contrast between density and emptiness gives matter its solidity, even though the structures within it resemble a silent, invisible constellation. A silent, invisible constellation lies at the heart of everything touched, held, or seen. Tables, mountains, oceans, stars, all are built from atoms arranged in different patterns. These atoms have endured since the earliest days of the universe, forged in the furnaces of ancient stars and scattered across space before gathering into new forms. Every element has its origin in stellar processes, and every atom has traveled far. Though they appear motionless in solid objects, their internal motions are constant. Particles move with energies that never fully cease, shape the strange stillness within atoms. Electrons do not orbit like planets. They behave more like standing waves, patterns of probability that describe where they might be found. Some regions glow with higher likelihood. Others remain nearly empty. The electron cloud hums with motion, though it cannot be seen. This hum is not noise, but the gentle vibration of quantum rules, rules that allow matter to exist, bond and interact, they do, though the mechanics defy everyday logic. Quantum behavior does not follow classical expectations. A particle can be in multiple states. It can behave like a wave. It can tunnel through barriers. It can exist in superposition, occupying many potential conditions at once until measured. These qualities create the foundation of atoms, shaping the world at its smallest scales. Yet they remain profoundly mysterious. Too, is the nature of the nucleus. Protons and neutrons clustered tightly, bound by the strong nuclear force, the most powerful force known, yet one that operates only across extremely short distances. If protons alone filled the nucleus, they would repel each other violently. But neutrons, acting as mediators, allow the structure to remain stable. The strong force binds particles with a grip that cannot be felt, yet holds the foundations of matter together. Foundations of matter together form a paradox of emptiness and intensity. The nucleus is tiny, yet contains most of an atom's mass. The electron cloud extends far outward by comparison, yet contributes little weight. The atom as a whole is light and delicate, but when trillions gather, they create mountains and planets. This blend of minuscule mass and vast space demonstrates how much of the world is built from structures that feel solid but are not truly dense. Solidity comes from forces, not closeness. Surfaces resist touch because electrons repel other electrons. This repulsion creates the feeling of solidity, even though particles never actually meet. Yet they interact constantly. Fields permeate space. Forces connect particles across gaps. Every electron carries a negative charge. Every proton carries a positive charge. These charges attract and repel, shaping the structure of atoms and molecules. However, the charges themselves remain mysterious. Scientists can measure them, predict their behavior, and describe their effects, but the reason charge exists remains elusive. It is a property, fundamental and unbroken, woven into the nature of matter. Is another mystery. Why electrons occupy discrete energy levels. They cannot move freely within an atom. They exist in quantized states, each with a specific energy. When an electron jumps from one state to another, it emits or absorbs a photon. This interaction between light and matter forms the basis of spectroscopy, allowing scientists to determine the composition of stars and gases, the colors of the universe, nebula, glows, auroras, starlight spectra arise from these quantum leaps. Yet the reason electrons follow quantized rules rather than continuous ones remains lightly veiled as well, is the uncertainty built into atomic systems. Heisenberg's uncertainty principle states that the position and momentum of a particle cannot both be known with precision. The more accurately one is known, the less precisely the other can be determined. This is not due to measurement errors, but to the fundamental nature of particles. They do not have exact positions until measured. They exist in a blur of possibilities. This blur forms the basis of quantum mechanics, shaping every atom and molecule, shaping every atom and molecule. Quantum mechanics governs chemical bonds. Covalent bonds form when atoms share electrons. Ionic bonds arise when charges attract. Metallic bonds allow electrons to move freely through a lattice. These interactions create the diversity of materials, the strength of metals, the clarity of glass, the fluidity of water. All emerge from the quantum behaviors of electrons. The world of touchable matter rests upon intangible rules. Smooth and quiet, smooth and quiet. The interactions inside atoms also reveal moments of stillness. Despite constant motion, atoms appear calm because their behaviors average out into stable patterns. Electrons populate energy shells. Nuclei remain bound. The entire atom behaves as a unit, even though it contains components with wildly different characteristics. This unity arises from balance, a balance maintained by forces that remain mysterious in their deepest foundations. Mysterious in their deepest foundations are the very particles themselves. Protons and neutrons are not fundamental. They are made of quarks, bound by quarks carry fractional charges, combining into whole charge particles. They come in varieties called flavors, up, down, strange, charm, top, bottom, whimsical names for deeply mathematical concepts. Gluons mediate the strong force, binding quarks into nuclei. Yet quarks have never been observed in isolation. Their confinement is so strong that they cannot break free without creating new particles. This property hints at limits within the structure of matter, layers that cannot be peeled back further. Layers that cannot be peeled back further lead to fundamental particles like electrons, neutrinos, and photons. These particles form the base of the standard model of physics. They behave consistently, predictably, and elegantly. But even this model does not explain everything. Dark matter eludes detection. Gravity remains disconnected from quantum theory. The universe contains symmetry and asymmetry in puzzling proportions. The atomic world, though mapped with extraordinary precision, still harbors quiet unknowns. Quiet unknowns gather within the concept of quantum vacuum, the empty space inside and outside atoms. What appears empty teems with activity. Virtual particles form briefly, then vanish. Fields permeate space, fluctuating softly. The vacuum is not silent, but humming with possibility. Energy exists even in the absence of matter. These fluctuations influence particles, affecting how they move, how they interact, how they acquire mass. The Higgs field, another pervasive entity, gives mass to particles through interaction, yet its nature remains only partly understood. 2 is the behavior of electrons under various conditions. In superconductors, electrons pair up and move without resistance. In semiconductors, electrons hop between energy bands. In insulators, they remain locked in place. These behaviors enable technology, computers, sensors, lights, but they also reveal the flexibility of atomic systems. Small changes in energy or arrangement can transform the way electrons behave, creating effects that feel almost magical in their precision. Atomic interactions affect biological systems as well. Life's processes depend on chemical reactions governed by electron movement, the folding of proteins, the copying of DNA, the signaling of neurons. Enzymes, lower energy barriers, guiding reactions gently. Membranes form through lipid interactions. Even thought and memory arise from the electrical activity of atoms arranged into intricate networks. Life exists because atoms behave in ways that support complexity, stability, and change. Complexity, stability, and change form a quiet trilogy within the atom. Complexity emerges from the combination of particles and forces. Stability arises through balance. Change occurs through interactions. This triad shapes both matter and meaning. It allows molecules to form, break, and reform. It allows energy to flow. It allows atoms to combine into the myriad structures found in the natural world. Soft leaves, cold stones, warm skin, shimmering water. Shimmering water offers another glimpse into atomic stillness. Water's properties, its cohesion, surface tension, density arise from hydrogen bonds. These bonds form because of the slight polarity within water molecules, an uneven charge distribution caused by the arrangement of electrons. This small asymmetry gives water its ability to support life, shape landscapes, and moderate climate. The world owes much to the quiet details within atomic structures. Quiet details within atomic structures also create colors. When atoms absorb and release energy, they emit specific wavelengths of light. These wavelengths determine color. The deep greens of forests, the blues of oceans, the warm hues of sunrise, all arise from interactions between electrons and photons. Color exists because of atomic behavior. It emerges from the spaces between particles, from transitions to small to see, from energies to subtle to feel, yet profound in consequence. Atomic forces shape everything from the hardness of minerals to the softness of clouds. The world's textures arise from the arrangement of atoms. Carbon atoms, arranged one waveform, graphite, soft and dark. The same atoms, arranged differently, form diamond, clear and hard. This transformation is not due to chemistry, but structure. The same ingredients yield entirely different outcomes because of the geometry within their atomic bonds. Geometry within their atomic bonds reflects another mystery: why atoms form the shapes they do. Electrons occupy orbitals with specific angular patterns, spherical, dumbbell-shaped, or more complex shapes. These patterns arise from quantum rules, not classical ones. They determine how atoms connect, influencing the shapes of molecules. The spirals of DNA, the rings of benzene, the branching of carbohydrates, all come from quantum geometry. These forms, natural and graceful, echo throughout biology and chemistry. Atomic patterns also appear in geological processes. Crystals grow according to atomic arrangements. Minerals form repeating structures. Salt crystals take cubic shapes. Quartz forms hexagonal prisms. Snowflakes develop unique patterns based on temperature and humidity. These structures, delicate and ephemeral, trace the movements of atoms as they settle into low-energy arrangements. Atoms seek stability. They favor configurations that require minimal energy. This tendency shapes chemical reactions. Atoms react to reach stable states. Bonds form and break according to energetic favorability. Even the explosions of stars follow this rule. Nuclei fuse into heavier elements until energy demands shift, triggering collapse. Stability and change, softness and intensity, simplicity and complexity all emerge from these atomic principles. Atomic principles extend into nuclear reactions, where forces reach their extremes. Fusion powers stars, releasing energy as light and heat. Fission splits heavy nuclei into lighter ones, releasing stored energy. Both processes reveal the immense potential within atomic cores. Yet this power remains contained in everyday matter due to nuclear stability. Most atoms exist in non-reactive states, their nuclei bound tightly, their energies balanced. Atoms form the world's quiet foundation, yet most of their structure is empty. If an atom were expanded to the size of a cathedral, the nucleus would be no larger than a grain of sand, while electrons would drift in the vast space between. This emptiness is not nothingness. It is possibility. It allows atoms to combine, move, and interact. It gives matter its flexibility and form. Without empty space, the world would be rigid and featureless. Rigid and featureless, the world is not. Atoms build landscapes, weather patterns, living bodies, and stars. They follow rules that allow for incredible diversity. The same particles that form air also form stone. The same forces that guide electrons in metals guide them in nerves. This unity of structure across scales creates harmony within the cosmos, connecting the smallest spaces with the largest ones. Connecting the smallest spaces with the largest ones is one of the most comforting truths in physics. The same laws that shape atoms shape galaxies. The same principles that guide electrons guide stars. This continuity suggests that the universe is woven from a single fabric, even if its patterns appear in different forms. Atomic stillness mirrors cosmic stillness. Both reflect a balance between motion and quiet, between structure and emptiness. Structure and emptiness merge again when considering particle-wave duality. Atoms contain particles that move like waves. Electrons have wavelengths. Their behavior depends on both momentum and position. This duality challenges intuition but enriches understanding. It shows that matter is not fixed, not rigid, not merely solid. It is fluid, dynamic, and delicate. Its essence lies between states, not one or the other, but both. Not one or the other, but both. This refrain echoes through quantum theory. Reality at small scales is not binary. It is layered and soft. Outcomes exist in possibilities. Attributes remain undefined until measured. This softness at the heart of matter creates a world that is stable yet flexible, predictable yet mysterious. It allows for creativity in chemical structures, for adaptability in biological systems, for richness in material properties. Richness in material properties extends into heat and temperature. Heat is the motion of atoms. Temperature measures this motion. When heated, atoms vibrate more quickly. When cooled, they slow. At absolute zero, atomic motion reaches its minimum, though quantum rules prevent total stillness. Even at this limit, atoms retain a faint hum, the zero-point energy. This hum illustrates that motion is inherent to existence. Stillness in matter is never complete. It is always a balance. A balance appears in the way atoms form solids, liquids, and gases. In solids, Atoms vibrate around fixed positions. In liquids, they slide past one another. In gases, they drift widely. These states depend on temperature and pressure, but all rely on atomic interactions. Matter transitions smoothly between these states, demonstrating the fluid boundaries within atomic behavior. Fluid boundaries within atomic behavior also shape quantum tunneling, a process where particles pass through barriers they should not be able to cross. This phenomenon occurs in nuclear fusion, radioactive decay, and even within cells. Without tunneling, stars could not shine. Enzymes might not function. The sun itself owes its existence to quantum effects unfolding in atomic cores. Unfolding in atomic cores, processes like fusion reveal another puzzling truth. The amount of energy contained in matter is immense. Einstein's equation, E equals mc, shows that even small amounts of mass can convert into enormous amounts of energy. Yet, this potential remains quietly hidden in everyday life. Atoms do not release their energy unless specific conditions arise. They exist in stability, radiating stillness rather than power. Radiating stillness rather than power. Atoms fill the world with gentle textures. The warmth of sunlight on skin arises from atomic vibrations transformed into infrared light. The fragrance of a flower arises from molecules interacting with receptors in the nose. The softness of fabric arises from the arrangement of fibers and bonds. These sensory experiences are all atomic in origin, yet they feel far removed from the abstract. Rules of quantum mechanics, far removed from the abstract. Rules of quantum mechanics are the sensations of calm that physical stillness can evoke. And now, in keeping with the slow rhythm of reassurance, there is room for quiet within small spaces. Ease can form even where structures are complex. Let that ease settle softly into thought. Let that ease settle softly into thought, because atomic stillness offers a metaphor for calm. Even when internal motions are constant, the overall structure remains stable. Even when electrons move rapidly, the atom feels still. Motion and stillness coexist. This coexistence mirrors the rhythms of life, where thoughts may drift, feelings may shift, yet a deeper stability remains quietly present, quietly present. 2 is the fact that atoms are ancient. Many formed in stars billions of years ago. Some traveled across galaxies before joining the Earth. Some passed through countless organisms. The atoms in a single breath may once have belonged to oceans, forests, clouds, or distant stars. Matter is always recycled. Forms change. Structures dissolve and reform. Yet the particles endure. The particles endure through time, carrying the universe's history in their quiet spaces. And here, as the chapter settles into its final descent, atomic stillness becomes a gentle bridge toward the mysteries waiting above mysteries, not of small scales, but of vast cosmic expansion and the quiet acceleration of galaxies drifting apart. And from the smallest spaces, the story rises now, drifting into the vast unknown above. The universe moves outward in all directions, stretching softly like fabric warmed by light. Galaxies drift apart over unimaginable distances, carried by a quiet force that has no name, rooted in everyday experience. This expansion is not a wind, nor a wave, nor a pressure. It is space itself increasing gently and steadily. The discovery of this expansion reshaped the way the cosmos is understood, revealing that the universe is not static but alive with slow motion and vast breadth. Yet, the reason this expansion accelerates remains one of science's most enduring puzzles, a mystery resting in cosmic darkness. Resting in cosmic darkness is a force called dark energy, a name that describes only its unknown nature. It accounts for most of the energy in the universe, yet it cannot be touched, seen, or detected directly. Its presence is inferred from the way galaxies move, the way light stretches, and the way large-scale structures evolve. Dark energy appears to push space outward, guiding expansion with a steady hand, but its origin remains hidden, its essence unspoken by the particles and forces known today. Unspoken by the particles and forces known today. Dark energy invites contemplation. It may be a property of space itself. It may be linked to quantum fluctuations. It may arise from fields that have not yet been understood. Regardless of its source, it influences the universe with extraordinary subtlety. Over billions of years, its quiet push accumulates, stretching distances between galaxies, clusters, and superclusters. This expansion does not tear galaxies apart or disrupt solar systems. Only the spaces between the largest structures grow, leaving smaller systems intact. Like islands drifting apart on a calm sea. Islands drifting apart on a calm sea resemble the galaxies as observed from Earth. Each galaxy is a gathering of stars, gas, and dust linked by gravity. The Milky Way contains hundreds of billions of stars, yet it is only one among countless others. And all of them drift away from one another, not because they choose to move, but because space expands around them. This motion can be measured through redshift, the stretching of light into longer wavelengths as objects recede. The red glow of distant galaxies is a soft record of cosmic expansion. A soft record of cosmic expansion lies in the cosmic microwave background, the faint radiation left from the early universe. This glow permeates all of space, quiet and uniform, with slight variations that reveal the universe's earliest structures. Over time, as the universe expanded, this radiation cooled. It now hums at microwave frequencies, a whisper of ancient heat. Its smoothness reflects the calmness of the early cosmos, while its tiny ripples reflect the seeds of galaxies. This afterglow carries within it the story of expansion, stretching from the moment the universe became transparent. Stretching from the moment the universe became transparent. Expansion has shaped everything that exists. After the Big Bang, matter spread outward. Gravity gathered some of it into clouds. These clouds condensed into stars. Stars formed galaxies. Galaxies formed clusters. Yet, throughout this process, expansion continued. Gravity pulled matter inward, while dark energy pushed space outward. The balance between these forces determined the universe's fate. For billions of years, gravity slowed expansion. Then, as the universe aged, dark energy began to dominate, causing expansion to accelerate. Causing expansion to accelerate, dark energy changed the trajectory of cosmic evolution. In the distant future, galaxies will drift so far apart that their light may no longer reach one another. Stars will burn out. Matter will spread thin. The cosmos will grow colder as space extends. This future, if dark energy remains constant, is known as the heat death, a state where the universe becomes diffuse and still. Yet this prediction rests on assumptions that may themselves evolve. Dark energy could change in strength. It might reverse. It might fade. The universe's future remains as uncertain as its origins. As uncertain as its origins is the reason why the Big Bang occurred. Expansion implies a beginning, but the nature of that beginning is not clear. Some theories suggest that space emerged from quantum fluctuations. Others propose cycles of expansion and contraction. Still others imagine multiverses where countless universes exist with different properties. These ideas stretch the imagination, but remain speculative. No measurement has yet revealed the mechanism behind cosmic birth. The universe's first moment remains hidden behind a horizon of time. Hidden behind a horizon of time. The early universe existed in states too extreme for current theories to fully describe. Temperatures and energies were beyond what any laboratory can replicate. Space was dense with particles and radiation. Forces behaved differently. Under such conditions, expansion began with incredible speed. Inflation, a rapid, exponential growth of space, smoothed irregularities, stretched fluctuations, and set the stage for the universe that followed. This inflationary period, though accepted widely, still lacks a clear cause. Why the universe inflated remains unknown. Remains unknown, too, is whether space itself has limits. It may be infinite, extending endlessly in all directions, or it may curve back upon itself, forming a cosmic loop. Observations favor a flat, nearly infinite universe, but the possibility of curvature remains open. Space could be finite, yet unbounded, like the surface of a sphere scaled into higher dimensions. These shapes, described by mathematics, are difficult to visualize, but reveal how flexible space can be. How flexible space can be becomes apparent in gravitational lensing. When light passes near massive objects, its path bends. Galaxies behind clusters distort into arcs or rings. This bending is not caused by a surface or barrier, but by the curvature of space itself. Gravity alters geometry. Space warps. Light follows these curves. Lensing reveals dark matter, maps mass distribution, and provides glimpses of galaxies too distant to observe directly. Through these observations, expansion becomes visible, not only in motion, but in structure. Visible not only in motion, but in structure. The universe's expansion emphasizes the scale of cosmic emptiness. Vast regions contain no stars, no gas, no dust. Filaments of galaxies thread through voids like delicate structures woven across darkness. These filaments form a cosmic web shaped by gravity, acting on matter after inflation. The web spreads across billions of light years, its silent geometry a testament to countless interactions over time. And through it all, expansion stretches the fabric further, yet does not disturb the quiet within galaxies. Stars orbit their centers calmly. Planets follow gentle paths. Dust clouds form and dissipate. Within galaxies, forces balance. Gravity binds. Nuclear processes shine. Chemical reactions unfold. Expansion affects only the space between galaxies. It is too weak to influence smaller structures. This separation of scales creates harmony, allowing cosmic processes to operate independently of the universe's larger motions. Stars evolve according to their masses. Small stars burn slowly, lasting trillions of years. Larger stars burn quickly, ending in supernova explosions. These explosions distribute heavy elements across space, enriching future generations of stars and planets. Expansion ensures these elements disperse widely. Without expansion, matter would remain clumped, limiting diversity. But expansion brings movement, spreading materials across great distances, allowing new combinations and new worlds to form. New combinations and new worlds reflect the creative potential of a universe in motion. Planetary systems emerge from clouds of dust and gas. Disks form around young stars. Grains collide and stick. Planets grow. Some develop water. Some form atmospheres. Some remain barren. This diversity arises from subtle variations in temperature, composition, and distance from the star. Expansion gives these systems their isolation, allowing each to evolve independently, shaped by local conditions. Galaxies also vary. Some spiral gracefully. Others form ellipses or irregular shapes. Some contain active centers powered by supermassive black holes. Jets of energetic particles stream from these centers, illuminating regions across millions of light years. Yet even these powerful jets fade as they travel, their energies stretched by the expanding universe. Expansion slows their reach, softens their brightness, and allows distant structures to drift into quiet solitude. Quiet solitude characterizes many regions of space. Between galaxies lie voids vast enough to dwarf clusters. These spaces are not entirely empty. They contain faint traces of particles and radiation, but they stretch for enormous distances without much structure. Expansion widens these voids, increasing the isolation of galaxies. As distances grow, interactions between galaxies become rarer. The cosmic web thins. The universe becomes more spacious, more open, more softly silent. The night sky holds another clue to expansion, the darkness between stars. If the universe were static and infinite, every direction would eventually meet a star, and the sky would glow brightly. Instead, darkness dominates. This puzzle, known as Olber's paradox, finds its answer in expansion. Because the universe expands, light from distant regions becomes stretched and dim. Because the universe has a finite age, light from the farthest reaches has not yet arrived. Darkness exists not because stars are few, but because space stretches and time limits what can be seen. Yet the light that does reach Earth carries messages from ancient eras. Distant galaxies appear as they were billions of years ago. Their shapes, colors, and movements reveal cosmic history. The farther the gaze travels, the closer one gets to the early universe. Observing deep space is like reading old pages of a cosmic diary. Each photon is a surviving word. Each galaxy is a recalled moment. Expansion preserves these memories, slowing their arrival. Slowing their arrival allows the past to coexist with the present. Spacetime is not merely a container, but a dynamic entity. Einstein's general relativity shows that mass and energy shape curvature. This curvature influences motion, time, and geometry. Expansion fits within this framework, but remains partially mysterious. The equations describe how expansion happens, but not why it accelerates. The underlying cause remains partly hidden, like a meaning beneath a poem that can be read but not grasped fully. Read but not grasped fully. The cosmos invites contemplation more than certainty. Its stillness, its distance, its quiet unfolding encourage a softer relationship with mystery. Not every question requires resolution. Some can rest gently, like dust settling in sunlit air. And here, as the story continues, a reassurance settles with it. It is all right for questions to remain open. Calm can fill the spaces where answers have not yet formed. Let that calm drift softly across the mind's horizon. Drift softly across the mind's horizon. The attention returns to the observable effects of expansion. Galaxies that are twice as far away move twice as fast. This relationship, known as Hubble's law, provides evidence for expansion. It reveals that space is stretching uniformly. Every point moves away from every other point. This does not imply a center. Expansion occurs everywhere simultaneously. The universe is not an explosion from a single point, but a continuous increase in distance throughout space. A continuous increase in distance throughout space also explains the cooling of cosmic radiation. As wavelengths stretch, radiation loses energy. The universe cools. This cooling influences the formation of atoms, molecules, and eventually stars. It shapes cosmic evolution in ways that remain subtle yet profound. Without expansion, matter might not cool enough to condense. With too fast expansion, matter might scatter too quickly to form structures. The universe follows a balance that allows complexity to emerge. The universe's expansion has guided the formation of large-scale structures, galaxy clusters, superclusters, filaments, and walls. These structures resemble delicate foam stretched across darkness. Gravity pulls matter into patterns. Expansion stretches those patterns outward. This dynamic interplay creates the cosmic web. Each filament contains galaxies. Each galaxy contains stars. Each star contains atoms. And each atom contains empty space filled with quantum possibility. Scale shifts, but the principles of structure and motion repeat. Structure and motion repeat in another phenomenon, baryon acoustic oscillations. In the early universe, sound waves rippled through hot plasma. These waves left imprints in the distribution of matter. As the universe expanded, the waves froze into place, forming subtle patterns. Today, astronomers can detect these patterns and use them to measure expansion. Though the waves themselves fell silent billions of years ago, their echoes remain, whispering through clusters of galaxies. These ancient imprints demonstrate that cosmic expansion is deeply tied to the universe's earliest moments. Expansion carries the memory of those moments forward. It shapes the paths of galaxies, the distribution of matter, and the future of cosmic evolution. Yet dark energy, though dominant, remains obscure. Its strength appears constant. Its influence appears uniform, but its nature remains unclassified. Beyond the known particles and forces, beyond the known particles and forces lies the possibility of new physics, fields or interactions that might explain dark energy. Some theories propose quintessence, a dynamic field that changes over time. Others suggest modifications to general relativity. Still others imagine energy trapped in space itself. These ideas remain speculative, awaiting evidence. The universe's expansion continues quietly, offering clues slowly, with the calm patience of cosmic time. With the calm patience of cosmic time, galaxies drift apart, stars burn, black holes grow, planets form, life emerges. Through it all, the expansion of space provides a backdrop, steady, silent, unhurried. The universe does not expand with urgency. It expands with softness, like breath moving through a sleeping world. Breath moving through a sleeping world mirrors the rhythm of cosmic expansion. Each moment stretches space a little more. Each second adds to the distance between galaxies. The scale is beyond everyday experience, yet the motion is gentle. It does not shake, disturb, or alarm. It flows quietly, shaping the fate of everything that exists, shaping the fate of everything that exists. Expansion reveals something profound. The universe is not static. It changes. It evolves. Its story unfolds slowly across billions of years. Even as structures form and dissolve, the expansion continues. And now, as the chapter draws toward its soft close, a final reassurance settles into the quiet theme of cosmic motion. There is ease in knowing that change can be slow. Space expands gently. Time moves steadily. Calm can follow that rhythm. Let that rhythm settle like dusk across the thoughts that drift. Let that rhythm settle like dusk across the thoughts that drift. For the universe's expansion guides the story onward. Each widening distance leads naturally toward the next question, not of galaxies or gravity, but of the living world below, where mysteries move with wings, waves, instincts, and calls carried through forests and oceans. And as space stretches softly outward, the story follows the rhythm of the living world below. Every creature carries a language shaped by its world, not always spoken, not always heard, yet profound in its quiet precision. This language stretches across forests, oceans, skies, and desert winds, forming a tapestry of signals older than cities, older than mountains, older even than the idea of language itself. These signals guide migration, reveal danger, summon mates, forge alliances, and coordinate movement in ways that science still struggles to fully understand. Among all the mysteries of the natural world, the languages of animals remain some of the softest and most intricate, drifting through habitats like threads of sound, scent, and motion. Threads of sound, scent, and motion shape communication in ways unseen by human senses. Whales speak across wide oceans with low frequencies that travel through deep water. Birds navigate by sensing magnetic fields invisible to the eye. Insects coordinate movements with pheromones carried on gentle breezes. Each species uses the channels available to it, forming networks of communication that operate quietly in the background of ecosystems. These channels appear simple from a distance, yet contain layers of meaning. When a whale turns its head to send a call in a particular direction, or when a bird glides along a faint magnetic line, it performs acts shaped by thousands of generations of evolution. Shaped by thousands of generations of evolution. These languages remain partly unexplained. Whale songs, for instance, contain patterns that shift slowly over time, as though following traditions. Some parts repeat, some fade, some evolve gradually, spreading from one region to another, like cultural changes. Scientists can analyze frequency, rhythm, and structure, yet the full meaning remains hidden. These songs may carry information about food, migration, or social bonds. They may serve purposes not yet imagined. The truth remains submerged in the ocean's vastness, carried by waves that hum across dark water. Hum across dark water also, the electromagnetic senses used by migratory birds. Many birds travel thousands of kilometers, following pathways through the sky with remarkable accuracy. Some return to the same tree each year. Others fly over oceans with no visible landmarks. Experiments suggest they sense the Earth's magnetic field through tiny proteins in their eyes, allowing them to see magnetic directions. But how the brain interprets such information remains largely unknown. It may appear as shifting colors, faint gradients, or soft patterns. The mechanism hides behind layers of biology. Subtle and elegant. Subtle and elegant, too, are the patterns in fish schools. Hundreds of individuals coordinate their movements almost instantly, turning in unison, shifting direction as though sharing a single thought. Their coordination does not rely on leaders. Instead, each fish follows simple rules: maintain distance, match speed, follow alignment. Yet the result feels almost choreographed. Scientists can simulate this behavior with algorithms, but the sensory experience of the fish remains mysterious. How they process such rapid information, how they avoid collisions, how they sense the subtle changes in flow remains partially understood. The silent communication of trees as well. Root systems intertwine with fungal networks, creating underground webs that transmit nutrients and chemical signals. These systems allow trees to sense stress, share resources, and adjust growth. A tree damaged by insects may release signals that warn others. A shaded sapling may receive nutrients from older neighbors. The forest operates like an ecosystem-scale organism, connected by quiet chemical messages. These signals are not conscious, yet they reflect deep intelligence, an intelligence rooted in survival, cooperation, and balance. Survival, cooperation, and balance also guide the communication of elephants. Their calls travel long distances through the ground as low-frequency vibrations. These rumbles allow herds to coordinate movement, reunite, and share emotional cues. Calves follow the direction of these vibrations. Adults adjust behavior based on subtle changes in pitch and timing. Yet the meaning encoded in these calls is only partly understood. Elephants appear to share complex social messages, recognizing individuals across great distances. Their communication reveals bonds that stretch across time. Familial threads woven with memory. Familial threads woven with memory appear in wolves as well. Their howls carry identity, location, and emotional state. A single howl may summon a pack, mark territory, or reassure distant members. Wolves adjust pitch, frequency, and duration depending on purpose. Their vocalizations contain layers of meaning that extend beyond simple signals. How these meanings are learned, how young wolves interpret their first howls, how packs coordinate through sound remains partly hidden behind forest shadows. Hidden behind forest shadows lie other mysteries, the dances of bees. Bees communicate the location of flowers through motions performed within dark hives. The angle of the dance, the duration, and the vibration indicate direction and distance. This language is precise, mathematical, and symbolic. Yet, the origin of this ability, how bees evolved to encode geographical information into physical movement, remains partly unexplained. Their dances form maps made of motion, softly guiding each forager toward blooming fields. Blooming fields attract pollinators of all kinds, insects, birds, mammals, each carrying signals embedded within movement and scent. Butterflies navigate by sunlight patterns. Ants follow chemical trails. Moths find mates using pheromones carried through night air. These mechanisms operate quietly, invisible to human perception. Their effectiveness is undeniable, yet their deeper intricacies remain elusive. Chemical communication, especially, involves complex molecules and subtle gradients. How animals decode these gradients into direction and meaning continues to inspire questions. The communication of dolphins. Their clicks and whistles contain structured patterns, some resembling names. Dolphins respond to specific call signatures, demonstrating recognition across distances. They coordinate hunts with precision, forming shapes and strategies in water. Their signals reflect intelligence shaped by social living and complex environments. Yet scientists cannot decode their language fully. The meanings behind certain whistles remain unclear. The scope of information held in each pattern remains unknown. Unknown, too, is the full extent of octopus signaling. Octopuses shift skin color and texture rapidly, communicating mood, warning others, or blending into surroundings. Their displays can be sudden or subtle, a flash of pattern, a ripple of color, a change in texture. Some signals appear social, others serve camouflage. The neurological control behind these patterns is extraordinary. Chromatophores, tiny pigment sacs beneath the skin, respond to signals from the brain almost instantly. Yet the rules governing these displays remain only partly mapped. Only partly mapped are the languages of primates as well. Monkeys and apes use vocalizations, gestures, and facial expressions to convey meaning. Some species have distinct calls for different types of predators. Others use gestures to request food, initiate play, or establish hierarchy. Chimpanzees combine signals into sequences, suggesting a form of syntax. Gorillas share emotional cues through posture. These systems resemble early foundations of human language, yet they remain distinct, shaped by each species' environment and evolutionary history. Animal languages extend beyond sound and movement into realms of electrical communication. Electric fish generate fields around their bodies. These fields create patterns that convey identity and mood. Some species use electric pulses to navigate murky waters. Others use them to coordinate with mates. These signals are faint, rhythmic, and invisible to most senses. They represent a form of language built from biology to fit the constraints of habitat. Constraints of habitat shape the languages of birds, perhaps the most familiar animal communicators. Birdsong fills forests with rhythmic patterns. Some songs mark territory, others attract mates. Many serve both roles. The complexity of birdsong varies widely. Some species have simple calls. Others learn elaborate sequences and can mimic sounds from their surroundings. The evolution of birdsong reflects both natural selection and cultural transmission. Young birds learn from adults, shaping traditions that shift across generations. How birds interpret rhythm, tone, and pattern remains partly hidden, but their songs reveal deep ties between communication and survival. Deep ties between communication and survival appear in bats as well. Bats navigate through echolocation, sending out high-frequency calls and interpreting the returning echoes. This system allows them to locate insects in darkness, avoid obstacles, and coordinate within large colonies. The precision of echolocation is remarkable. Bats can detect objects smaller than millimeters. They adjust frequency based on distance, density, and movement. Yet, the neurological processes behind this interpretation of echoes remain partly uncertain. Echolocation represents a language of sound and silence, shaped by darkness. Shaped by darkness, the communication of cave-dwelling species often relies on tactile signals. Some fish use gentle contact to coordinate movement. Blind salamanders communicate with subtle touches. Crickets in caves tap surfaces to send vibrations. These methods bypass vision entirely, relying instead on physical cues. Each species adapts communication to its surroundings, forming systems that reflect constraints and opportunities. Communication can also involve color. Many reptiles and amphibians shift hues to signal aggression, readiness to mate, or camouflage. Chameleons adjust color based on mood, light, and temperature. Frogs display bright colors as warnings, yet the internal mechanisms linking environment, emotion, and color change remain partly unexplored. Color in these species becomes a language of light reflected softly across skin. Light reflected softly across skin leads to another form of signaling, bioluminescence. Fireflies use flashes to attract mates. Deep-sea creatures glow in darkness to lure prey or confuse predators. Some species communicate through synchronized pulses, creating waves of shimmering light. These displays rely on chemical reactions involving luciferin and oxygen. The patterns are rhythmic, timed, and often species-specific. But how these patterns evolved, how species developed recognition systems, and how brains interpret bioluminescent signals continue to raise questions. The languages of social insects. Ants coordinate enormous colonies with chemical cues. Termites build complex structures, guiding each other with traces left behind. Bees defend hives through alarm pheromones. These signals are efficient, yet subtle. A small change in chemical composition can alter meaning. The precision required for such communication is remarkable, especially given the small size and simple nervous systems of these creatures. How these systems evolved remains partly unknown, as well are the communication methods of corvids, crows, ravens, and jays. Corvids demonstrate intelligence, memory, and problem-solving. They use vocalizations, gestures, and tool-related signals. They recognize individual faces. They share warnings. Some even engage in playful exchanges that appear to involve humor. Their communication reflects advanced cognition, yet the full scope of their language remains beyond decoding. The meaning behind certain gestures, the nuances of their calls, the emotional depth of their interactions continue to inspire study. The quiet coordination in herds and flocks. Starlings form murmurations, swirling shapes in the sky. These patterns arise when individuals respond to the movements of neighbors, but the sensory mechanisms remain partly mysterious. Hoofed animals coordinate migrations across plains, following cues embedded in the environment. Some cues relate to rainfall, others relate to magnetic fields. The full mixture of factors remains open to discovery. Open to discovery, too, is the communication of marine invertebrates. Squid and cuttlefish display rapid color changes, creating patterns that shift across their skin. These patterns may signal threat, curiosity, or readiness to mate. Some species create waves of color that ripple across their bodies, resembling fluid motion. The complexity of these displays rivals spoken language. Their meaning, however, is only partly understood, shaped by interpretations drawn from observation. The languages of animals reveal a world rich with meaning that exists independently of human interpretation. These languages developed long before written words, long before symbolic systems. They arise from survival, emotion, instinct, and environment. They do not require grammar to convey urgency. They do not require vocabulary to share direction. They flow from signals embedded deeply in biology. Embedded deeply in biology are the molecules that carry scent. Many mammals rely heavily on smell for communication. Wolves mark territory. Big cats leave scent trails. Deer sense pheromones in the air. These messages carry identity, status, and boundaries. Humans have limited sensitivity to such cues. But in many species, scent forms a powerful and primary language. How animals interpret complex mixtures of molecules remains partly obscure. Yet undeniably profound, is the emotional dimension of animal communication. Many species express comfort, fear, playfulness, or distress through sounds and gestures. Horses flick ears to signal attention. Dogs use posture to convey trust. Birds raise feathers in excitement. Elephants gather around injured companions, sharing low rumbles that soothe. These emotional signals show that communication is not purely functional. It can carry connection and empathy. Connection and empathy shape many species' social dynamics. Primates groom each other to reinforce bonds. Dolphins support sick members. Orcas share food with young. These acts require communication that extends beyond simple cues. They involve shared understanding and social awareness. Yet the mechanisms through which animals convey emotional nuance remain partly unknown, residing in intonations, postures, and rhythms not yet fully mapped. The languages of animals continue to remind the world that intelligence and expression take many forms. Communication is not confined to speech. It can appear as vibration, color, scent, pattern, or movement. Each form reflects the environment that shaped it. Each form carries meaning tailored to survival. Here, as the chapter settles deeper into its calm rhythm, a quiet reassurance rises through the reflection. It is all right for meaning to remain gentle and unspoken. Understanding does not need to be complete. Let the simplicity of signals feel steady, settling like soft rain across the surface of thought. Settling like soft rain across the surface of thought. The chapter begins to drift toward transition. The strange languages of animals whisper through ecosystems with grace, unity, and mystery. They reveal forms of intelligence embedded not in words but in rhythm and instinct. And these rhythms, the beats of wings, the songs of whales, the scents that float through forests, all led naturally toward deeper mysteries within the bodies that perceive them. And from these living mysteries, the story glides toward something even closer, the mystery within ourselves. The human body holds mysteries shaped by time, adaptation, and quiet biological rhythms that unfold beneath awareness. Within each cell, processes continue with a precision that has guided life for millions of years. Muscles contract through unseen chemical exchanges. Neurons send signals through delicate networks of ions. Tissues heal themselves with slow, deliberate motion. And throughout all of this, countless secrets persist, secrets that science has studied, measured, and mapped, yet not fully understood. Not fully understood is the nature of sleep itself. The body enters cycles of rest, drifting through stages marked by shifting brainwaves and rhythmic breaths. Muscles relax, heart beats, cells repair. Memory reshapes itself in subtle ways. Yet, the deeper reason sleep exists, not just biologically, but evolutionarily, remains partly unknown. Some theories suggest that sleep supports memory consolidation. Others propose it regulates metabolism or restores the immune system. But none capture the full picture. Sleep remains one of the body's softest secrets. Unfolding each night like a ritual, the brain has never forgotten. Never forgotten. The cycle continues even when consciousness fades. Dreams appear as images stitched from memory, imagination, and emotion. They carry fragments of experience, rearranged into scenes without logic. Sometimes they echo the day. Sometimes they arise from older memories. Sometimes they drift into forms with no recognizable origin. Neurologists can observe the electrical patterns of dreaming, yet cannot determine precisely why dreams occur. The phenomenon remains partly shrouded, like mist rising from a quiet lake at dawn. Mist rising from a quiet lake at dawn resembles the way thoughts form. Neural networks exchange signals faster than any deliberate intention could track. A thought begins as a small electrical pulse, traveling through pathways shaped by experience. These pathways shift slowly over time, strengthened by repetition, weakened by neglect. Yet the emergence of a thought, the moment it becomes felt, remains unexplained. Even the simplest idea originates from processes too complex to perceive in full. Too complex to perceive in full. The immune system operates with a quiet intelligence. It identifies threats, remembers past encounters, and adapts to new challenges. Cells communicate through chemical signals, moving to areas that need defense. Some cells engulf pathogens. Others release targeted molecules to neutralize invaders. Memory cells persist for years, ready to respond quickly to familiar threats. Yet the system's ability to distinguish self from non-self is not absolute. Autoimmune conditions arise when this distinction falters, revealing gaps in understanding. The balance between defense and tolerance remains one of biology's unsolved puzzles. One of biology's unsolved puzzles also lies in the phenomenon of intuition. People often react to subtle cues without conscious awareness. A feeling arises, guiding action or perception, before reason has time to intervene. This intuition may stem from rapid neural processing, from past experiences stored in hidden networks, or from bodily signals interpreted quickly. But the mechanism behind such rapid, unconscious judgment remains elusive. Science can trace parts of the process, but not the spark itself. Not the spark itself, but the effect is familiar. The heart responds to emotion before it is fully recognized. Skin flushes with warmth during certain feelings. Muscles tighten or relax based on unseen influences. These reactions arise from the autonomic nervous system, which regulates internal states without deliberate control. This system adjusts heart rate, digestion, and breathing through signals that move quietly through the body. Yet the full interplay between emotion and physical response remains partly unexplained. As well is memory, not just the formation of memories, but their persistence. Neurons strengthen connections through repetition. Proteins change shape. Entire networks reorganize. But why some memories fade while others endure remains unpredictable. Emotional significance plays a role. Sleep influences storage. Repetition reinforces patterns. Yet the precise mechanism that distinguishes a fleeting moment from a lifelong memory remains hidden within the architecture of the brain. Hidden within the architecture of the brain are billions of synapses, each shifting over time. These synapses change strength based on use. This process, known as plasticity, underlies learning and adaptation. It allows the brain to rewire after injury, to refine skills, and to adjust to new environments. But the rules governing plasticity, when it occurs, how much it occurs, and why it varies between individuals, remain imperfectly understood. Plasticity displays freedom and constraint in equal measure. Freedom and constraint shape another biological mystery, the regulation of body temperature. The body maintains warmth through chemical reactions, blood flow, and shivering. Sweating cools the skin. Blood vessels expand or contract to adjust heat distribution. Yet some animals regulate temperature far more efficiently than humans, and the origin of these differences remains unclear. Even within humans, variations exist. Some tolerate heat easily, others cold. Metabolism, hormones, and genetics all contribute. But the precise balance remains to be mapped, the full nature of pain. Pain signals danger, prompting protective action. Yet, the experience of pain does not always correlate with the severity of injury. Some injuries cause little pain. Some minor triggers cause intense discomfort. Chronic pain can persist without a clear physical source. Pain is shaped by biology, emotion, and memory. It protects, warns, and sometimes confuses. Understanding its full complexity remains an ongoing study, revealing layers of perception and sensitivity. Layers of perception and sensitivity extend into the senses themselves. Vision depends on photons striking retinal cells, triggering chemical changes that send signals to the brain. Yet, color perception varies between individuals. Taste receptors differ in number and sensitivity. Sound waves travel through the ear with delicate precision, yet hearing changes with age and environment. Smell involves receptors attuned to tiny molecular differences. Touch relies on nerve endings tuned to pressure, temperature, and vibration. The integration of these senses forms a unified experience. Yet the stitching of these signals, how they become a coherent world, remains partly unknown. How the body maintains balance. Inner ear structures filled with fluid detect rotations. Tiny crystals sense changes in gravity. Muscles adjust posture with rapid responses. These mechanisms form a subtle coordination that operates constantly. When one part falters, dizziness or instability arises. Yet the precision of this system, how it calibrates itself, and how it adapts to new conditions, remains subjects of exploration. Subjects of exploration also include the circadian rhythm, the internal clock that guides sleep, hunger, temperature, and hormones. This clock synchronizes with light and dark, adjusting through specialized receptors in the eye. Yet the origin of circadian timing lies deeper, within genes that activate and silence themselves in rhythmic cycles. These cycles exist in nearly every cell, forming a distributed timing network. How this network remains synchronized across organs remains only partly understood. Only partly understood is the way hormones influence mood. Chemical messengers like serotonin, dopamine, and cortisol shape emotional states. But these chemicals interact through networks too complex to map fully. A single change in one hormone can ripple across systems, influencing sleep, appetite, and energy. These interactions reflect both precision and softness, revealing that emotional life is tied to biology in ways still unfolding. Still unfolding is the understanding of longevity. Cells age through gradual damage. Telomeres shorten. Proteins mitochondria lose efficiency. Yet some organisms live far longer than expected based on size or metabolism. Some animals regenerate tissues indefinitely. Humans exhibit wide variation in lifespan. The reasons behind these differences, genetics, environment, chance, remain partly hidden. Aging reveals patterns, but not a complete explanation. A complete explanation remains out of reach when considering the way the body heals. Wounds close through cascades. Blood vessels grow toward damaged tissue. Collagen forms scaffolds. Skin rebuilds in layers. Yet scars form differently based on countless factors, and some tissues regenerate better than others. Why the liver can regrow while nerves often cannot remains partly uncertain. Healing is both predictable and mysterious, following rules only partly known. Rules only partly known govern immune memory as well. After an infection, memory cells linger, ready to respond. Vaccines use this mechanism, to prepare the body. Yet the duration and strength of immune memory vary widely. Some responses fade quickly, others persist for a lifetime. The reasons behind these variations remain topics of deep study, interwoven with genes, environment, and cellular behavior. Cellular behavior also shapes metabolism, the conversion of food into energy. Metabolism depends on enzymes, hormones, and mitochondrial function, yet individuals vary greatly in metabolic rate. Some convert energy quickly, others conserve it. Stress, sleep, and environment affect metabolism, but the underlying roots of variation remain partly hidden. The body's energy balance reflects complex interactions across organ systems. Complex interactions across organ systems appear in another phenomenon. The body hosts trillions of microorganisms, bacteria, fungi, and viruses that influence digestion, immunity, and even emotion. These microorganisms communicate with cells through chemical signals, forming partnerships that remain partly unexplained. Differences in microbiomes influence health in ways only recently discovered. Yet the full map of these influences remains to be drawn. Remains to be drawn also the complete role of glial cells in the brain. Once thought to provide only support, glial cells regulate neurotransmission, clean cellular waste, and guide development. They influence memory, healing, and emotional states. Yet their full capabilities remain partly uncertain. The brain's architecture is more intricate than once imagined, with hidden layers of regulation unfolding silently in the background. To also operate the rhythms of breathing. Breath adjusts to emotion, sleep, and movement. It carries oxygen to tissues, removes carbon dioxide, and supports cellular energy production. Though breathing appears simple, its regulation involves networks of neurons in the brainstem that respond to countless signals. This regulation remains partly mysterious, especially the connection between breath and calm. Slowing breath often quiets the mind. The mechanism behind this connection lies in complex interactions between nerves and hormones. Still being uncovered are the signals that guide fetal development. Cells differentiate into tissues. Tissues shape organs. Organs coordinate into systems. Each step requires precise timing. Genes turn on and off in complex sequences. Chemical gradients guide growth. Small errors can alter development profoundly. Yet, for most individuals, development proceeds smoothly, guided by processes not fully mapped. The origins of form, why hearts develop on the left, why brains fold as they do, remain partly unknown. Partly unknown is also the phenomenon of human emotion, not in experience, but in origin. Emotions arise from neural activity, but why certain stimuli produce specific feelings remains incomplete. Joy, fear, grief, and calm arise from biochemical processes, yet they also carry meaning beyond biology. Scientists can observe patterns in the brain but cannot capture the subjective experience. Emotion remains both a biological mechanism and a personal landscape. A personal landscape shaped by countless signals. The body holds memory in muscles as well. Muscle memory allows skills to become automatic: walking, writing, playing an instrument. Neural circuits strengthen through repetition, forming pathways that need little conscious effort. How these pathways form so efficiently, and why they persist so long, remains partly unexplained. The body remembers in ways deeper than language. Deeper than language also lies the communication between organs. Hormones released in one area influence cells elsewhere. The heart sends signals to the brain. The brain influences digestion. The gut produces neurotransmitters that affect mood. These connections form a web of communication that extends through tissues. The full complexity of this network remains mapped only in outlines. New links emerge each year, hinting at systems more integrated than once imagined. More integrated than once imagined. The body also maintains rhythms across time, rhythms of growth, healing, and change. Bones remodel over years. Blood cells renew over months. Skin regenerates over weeks. These cycles create continuity. Yet the rules governing these cycles, their timing, efficiency, and adaptation, remain partly uncertain. Time shapes the body, but the body shapes its own sense of time. The body also hosts rare phenomena, difficult to explain. Some individuals withstand cold with unusual resistance. Others exhibit extraordinary endurance. Some heal rapidly. Some experience synesthesia, where senses merge, colors accompanying sounds, shapes accompanying tastes. These variations reveal hidden capacities, suggesting that the body's potential is greater than fully understood. Greater than fully understood are the forces guiding growth and repair. Chemical gradients pull cells into patterns. Mechanical forces influence division. Electrical signals shape tissue organization. These forces operate without awareness, guiding development through subtle interactions. Understanding these interactions remains one of science's ongoing efforts. Continue to explore how memories interface with emotion. The brain stores emotional memories differently from neutral ones. Strong feelings encode themselves deeply. Yet the mechanism behind this intensity remains only partly known. Neurotransmitters like norepinephrine and dopamine play roles, but the full orchestration involves networks beyond current understanding. Beyond current understanding is also the phenomenon of consciousness, the subjective experience of being aware. The brain processes information constantly. Signals travel through networks. Regions activate and deactivate. Yet, the moment these processes become awareness, the point where sensation becomes experience, remains one of science's largest mysteries. Consciousness emerges from matter, but how remains unknown. Yet deeply embedded is the body's quiet resilience. It adapts to stress, repairs injury, learns from experience, and maintains balance. This resilience is not absolute, but it is profound. Cells work tirelessly. Organs coordinate seamlessly. Systems stabilize through countless feedback loops. And through it all, mystery rests at the foundation. The body knows more than it speaks and expresses more than it reveals. Here, a soft reassurance emerges from this reflection. There is calm in trusting what works quietly. The body carries wisdom shaped by ages. Let that wisdom feel steady, resting like soft earth beneath the shifting surface of thought. Resting like soft earth beneath the shifting surface of thought. The chapter turns gently toward its final descent. the body's quiet secrets, from memory to intuition, from dreams to immunity, from breath to emotion, all reveal a single truth: complexity can exist in harmony. Mystery can coexist with understanding. Biology can unfold without full explanation. And as these mysteries settle, the story returns to the quiet path guiding the night's journey, drifting toward the soft close that waits ahead, where reflection meets gratitude and the final calm begins. You've traveled through silence and science tonight, moving softly across the edges of the known world. The mysteries that live in galaxies, in oceans, in tiny particles, and in the body itself have unfolded slowly, drifting like gentle currents through the dark. Each one remained partly unanswered, yet each carried a quiet beauty, a reminder that not everything must be solved before rest can settle in. You arrived here carrying whatever the day asked of you. And now those thoughts sit a little farther away, softened by distance and time. Softened by distance and time, the journey seems different now. The paths through consciousness, gravity, light, origins, atoms, expansion, animal languages, and the body's hidden workings all blended into one long exhale. And in this exhale, something inside begins to loosen. Curiosity reshapes itself into calm. Wonder drifts into stillness. The questions remain, but their weight grows lighter, as though each one has settled onto a quiet shelf of night where they can rest without urgency. Rest without urgency. That feeling rises gently around you now. Through every chapter, the unknown has been a companion rather than a puzzle. Darkness became a place to breathe. Silence became a place to listen. Mystery became a place to drift. In this final stretch of the night, those spaces expand a little wider, making room for comfort and softness. Nothing pulls or presses. Nothing asks for effort. The unanswered places simply hold themselves open, inviting peace. Inviting peace, the mind begins to reflect in quieter tones. Throughout the vastness of the universe, so much remains beyond understanding. Yet existence continues in harmony, carried by forces both mapped and unmapped. Galaxies drift through space. Stars burn and fade. Atoms shimmer with uncertain positions. Oceans breathe. Animals speak in languages shaped by instinct. And the human body moves through its rhythms with precision shaped by time. These patterns whisper one message: not knowing is part of living. Part of living is allowing mystery to remain intact. The world does not require full comprehension to be gentle. It does not need answers to feel whole. The sky still glows. Water still moves. Light still bends. Life still unfolds. And the night still carries its own quiet order, even when the details remain hidden. There is comfort in that, a soft sense that the unknown is not an obstacle, but a horizon, something that stretches beyond thought, offering depth rather than demand. Offering depth rather than demand. The night air around you seems to slow. Sounds soften. Shapes blur. Thoughts wander more lightly across the surface of awareness. A small comfort rises in the stillness. It's all right to drift for a while. Let the edges soften. Let the moment feel gentle. These quiet reassurances settle into the space between breaths, creating room for rest to deepen. Deepen now. The reflection turns toward gratitude. You have carried yourself through a long journey tonight, moving through realms vast and intimate. You allowed space for wonder, for thought, for quiet awe. You allowed silence to speak where words could not. In doing so, you honored the soft places within yourself that ask only for time and stillness. These places open wider now, welcoming ease. Welcoming ease, the mysteries encountered tonight linger like distant constellations, present but not pressing. The shape of the unknown stretches across the mind like a dark sky scattered with faint stars. Each question shines with its own gentle glow. Why consciousness feels like awareness. Why gravity bends space. Why light behaves in two ways at once. How life blossomed from non-living matter. Why atoms settle into patterns of uncertainty. Why the universe expands into silence. How animals speak their soft languages. How the body carries secrets deeper than thought. All of these mysteries join into a single quiet truth. The world holds more than can be explained, yet it remains a place of balance. A place of balance reveals itself through repetition, breath following breath, heartbeat following heartbeat, night following day. These natural rhythms continue, whether understood or not. They offer stability, anchoring the senses. Beneath every question lies a foundation of motion and rest, expansion and contraction, activation and calm. And through this rhythm, reassurance emerges again. Ease rests within reach. Let the night hold whatever remains unanswered. Whatever remains unanswered can rest gently in the background now, like soft wind against a window. The mind no longer needs to chase meaning. It no longer needs to connect each idea to the next. The world carries itself without being solved. Reality unfolds without needing explanation. This offers a kind of freedom, a release from the pressure to understand everything. The unknown becomes a blanket rather than a boundary. A blanket rather than a boundary. The darkness feels warmer now. The weight of the body grows softer. The breath steadies. Thoughts slow. The night gathers its quiet around you, wrapping each moment with stillness. Nothing needs to rise. Nothing needs to fall. Everything simply drifts, and drifting brings a deeper calm, the kind that hums beneath the surface like a low, comforting resonance. A low, comforting resonance continues as the journey turns inward. Throughout the chapters, the stories flowed outward into the cosmos, into oceans, into forests, into microscopic realms beneath perception. Now the direction shifts gently inward, toward the quiet center where awareness settles. This center does not demand attention. It does not require clarity. It simply exists, steady and patient. And in this patience, reassurance returns. It's fine to let thoughts fade. The night will carry what you set down. The night will carry what you set down. And as these words echo softly, the entire journey begins to gather into one final shape. Not a map, but a feeling. A long, slow feeling of drifting through places untouched by certainty, accompanied by gentleness and quiet wonder. A feeling of moving through darkness that comforts rather than hides. A feeling that the unknown can rest alongside the known without conflict. Without conflict, the stories settle deeper. The galaxies expand in silence. The atoms shimmer. The body breathes. The animals whisper in their own languages. Everything continues, each mystery living in its place, shaping the world in soft, unspoken ways. And slowly, thought begins to loosen further. There is no need to hold on to any detail. The night can carry the weight of the world. The mind can drift into stillness, the senses quiet, a faint scent, a low hum, a soft glow. At the edge of imagination, these impressions dissolve gently into the background. The narrative that carried you here becomes lighter, more diffuse. The story becomes less about understanding and more about resting. And in that shift, another comfort appears. You are allowed to rest in the presence of what you do not know. Let calm rise slowly. Let it fill the space around you. Let it fill the space around you. And the reflection turns toward the path traveled. The chapters stretched across different scales, from the smallest particles to the largest cosmic structures, from oceans of sound to forests of instinct, from the language of atoms to the memory held in bone. Through each scale, the night remained steady, holding the journey in quiet arms. And now, it brings you gently to the closing space, where rest expands like a slow-moving tide. A slow-moving tide hums beneath the next breath. The world outside grows distant. The world within feels soft. Every unanswered question turns into a small, glowing ember, warm but not demanding. These embers drift into the quiet, settling wherever they feel weightless. And in that weightlessness, the body begins to release its final tension. Shoulders loosen, the jaw softens, the breath deepens, and the night gathers all the unspoken thoughts, the gentle mysteries, the slow reflections, and cradles them in a stillness that does not ask anything more of you. The journey has no test, no conclusion, no lesson to remember. It offers only peace, the peace that comes from wandering gently through the unknown, letting wonder exist without pressure. Without pressure, the world feels softer, time stretches, the mind quiets, the story folds around you like a soft and endless blanket. And in this quiet gratitude forms, not rushed, not declared loudly, but rising slowly like a calm tide. Thank you for walking this path. Thank you for allowing silence to speak. Thank you for welcoming the mysteries that drift through night. And as gratitude settles, one final reassurance arrives, meant only for the quiet part of you that listens underneath thought. If you're still here, your body already knows what peace feels like. Let that feeling stay for as long as it wishes. Let it move gently, warm and steady. Warm and steady, the night holds its final breath, waiting only for rest to unfold. You have reached the soft edge of the journey, the place where stories fade, where questions dim, where stillness opens wide and inviting. Nothing more needs to be explored. Nothing more needs to be named. The quiet is enough. Thank you for sharing this quiet space. Good night.